On the surface, networking in iOS looks pretty simple, but under the hood, it's actually one of the most complex systems in your entire app and has a massive impact on performance and the overall user experience. And the reality is, most developers today don't even know what they're missing. There are entire systems, caching, retry systems, authentication flows that just aren't covered in most tutorials. And honestly, a lot of the networking code you see online won't survive in a real production environment. Not because it's wrong, but because it's incomplete. So that's what this advanced networking course is all about, filling in the missing pieces so that you can build a production-ready networking system. I'm Stefan, an ex-Meta iOS engineer, and I've spent years building apps that deal with real users, real data, and real scale. This course is focused on the part of networking that actually matters in production, the systems behind the requests. This isn't just some beginner course where we hit some endpoints and decode some JSON, or maybe implement some simple pagination. We're building a production-grade networking layer, something that you can actually reuse across your applications. By the end, you'll have a system that handles performance, reliability, and scale, not just fetching data from an API and displaying it in your application. So let's talk about what you're going to learn in this course. We're going to start by building a clean, reusable API client that supports all HTTP methods. So that includes get, put, post, and delete operations. And then we layer in real-world authentication. And I'm not talking about Firebase auth or something like that. We're doing JWT auth with token injection, secure keychain storage, and automatic token refreshing. And then we go deep into caching, designing systems that reduce API calls, improve performance, and even support offline mode. And we also implement smart retry strategies and logic with exponential backoff, so your app handles failures gracefully instead of breaking. And we also build real-time features using WebSockets, persistent connections, live updates, and reconnection strategies as well. We'll also handle file uploads and downloads with progress tracking and background support like real apps do. Then we secure your app with SSL pinning, protecting against man-in-the-middle attacks for that added layer of security. And we add logging and metrics so you can actually understand what's happening in your networking layer step by step. Plus advanced pagination systems and robust error handling so your app scales cleanly as your data and your user base grows. The difference with this course is simple. We're not building demos, we're building real-world systems. Everything is designed in the way you'd actually implement it in a real production app. And this is the gap between tutorial code and actual real-world software engineering. But don't just take my word for it. Let's take a look at what some other engineers are saying about this course. Tito Shiro, a former engineer at Apple and Meta, said that he's extremely picky about code quality, and Stefan's is some of the best I've seen. These aren't just tutorials, they're production-grade systems you can actually build on. CJ Rora, another iOS instructor at a different academy who takes my courses, says Stefan has a rare ability to take complex iOS concepts and make them genuinely easy to understand. The course structure is incredibly well thought out, and everything is up to date with modern frameworks and best practices. So if you're an iOS developer who wants to build better apps, stand out in interviews, or move from this works to this is actually production ready, this course is for you. Here at App Stuff, we're all about helping you move from beyond the basics into building advanced real-world production-ready systems that help you and your apps stand out. And you simply won't find this level of depth or advanced content anywhere else on the internet when it comes to iOS development. Everything we teach is straight to the point with real-world examples. There's no nonsense here. We don't waste anybody's time. We teach you the stuff that's used in the real world at the highest level. So if you guys are ready to get started with building advanced production-ready networking systems, let's go ahead and dive in. Look forward to seeing you inside the course. Stefan here, saying peace out. What is going on, everybody? Stefan here from App Stuff, and I'd like to welcome you to the first tutorial in the advanced networking course. So what we're going to be doing in this video is checking out this starter project that we have here This is available for download in the resources section of this lecture. So make sure you guys download that, get it opened up in Xcode, and come back to the video once you've done that. We're going to do a quick overview of the code. And after that, we are going to get started with implementing our networking layer to actually fetch products from an API. Right now, this is just mock data. So let's just do a really quick 30-second overview of the code. We have our content view. Our content view loads our products view. This is just a scrollable list of products. Each one links to a product detail view. And you guys can just take a look at the code here, and it should be very simple to understand. There's the product card view and the detail view. Here is our product model. It's very simple and straightforward. This is built off of the documentation that comes from our API, which we'll open up in a second. So here's our product. We have some mock data, and all of this is simply displayed in our products view, and it is loaded by our view model. So products view model here, and we can see here that there's no networking implemented yet. We are just loading our mock products here in this load products function, and that is called in a task in our main products view. So this should be really simple to understand. If this is at all difficult for you to understand, I would recommend starting off with our advanced networking course, our Swift networking masterclass, and then come back to taking this advanced networking course. This is a follow-up or continuation of the networking masterclass. So guys, now that we have an overview of the code completed, let's go ahead and take a look at our API. So we are going to be using this fake API.platzi.com. The link will be displayed on screen. You guys should just head there and get the documentation opened up. So if we just click on Platzi Fake Store API, you can just go to View Docs, and then we are going to go to Products here. So this gives us detailed documentation on how to fetch products from this API. And here is what each product will look like that is already modeled out for us. So if you guys can look through the rest of the documentation, it has info on how to create a product, how to update a product, delete a product, pagination. We are going to be implementing all of this stuff in this product section of the course. So guys, what we're going to do next is hop back into Xcode and get started with implementing our networking layer. So the first video, a couple videos of this course even, are going to serve as a bit of a refresher. We are just going to go over some pretty basic networking stuff to make sure you have a solid footing and foundation in your networking abilities. So we are simply going to be getting started with fetching our products from our API and displaying them on screen. And we will get more and more advanced as the lessons go on with more advanced networking topics. So let's go ahead and hop into our view model and get started, guys. I want to talk about architecture to start this off. As you probably know, the best way to do this, in my opinion, is through the use of dependency injection. So we need to build out a service, inject that service into this view model. We are going to make it a protocol-oriented service, and that will give us the ability to create mock services and utilize dependency injection and dependency inversion principles so that we have a really solid architecture to start things off. If you guys have taken courses with me in the past, you should be very familiar with this pattern. So let's go ahead and jump right in. So in this file, we're just going to create our product service really quickly. So we're going to have a product service. And we also mentioned that we wanted to have a protocol-oriented service here. So we're going to create a protocol called Product Service Protocol. And we're going to start this off by just having one function called fetch products. And it's going to be async throws, and it's going to return an array of products. And we are then going to conform this service to our product service protocol. And then we're also going to make a mock service. So we can just copy and paste this stuff, and we can call this mock product service. And both of these things are going to conform to this protocol. Once again, you guys have probably seen this pattern before. This is just to serve as a refresher so that we start things off the right way. So now we need to implement this, guys. So let's just go ahead and hit this red circle, hit apply. And here we'll just copy and paste that into our mocked product service. And here we could just simply say return product.mockProducts. And here we can just start off by returning a blank array. And we'll clean these files up here in a little bit. I just wanted to get started with our dependency injection. So next up, we're going to have a private property for our service. And this is going to conform to or be of the type product service protocol. So this is not going to be a concrete type, it's going to be an abstract type, so that we can inject anything in here that conforms to that conforms to this product service protocol. So we'll be able to swap between these two services seamlessly because they both conform to this protocol. So next up, we're just going to say init service, product service protocol, self.service is equal to our service. And then here we are going to wrap this up in a do catch block. And we're going to say, self.products is equal to try await service.fetch products. And here, for now, we're just going to have a print statement that says print debug failed to fetch products with error. And we're going to interpolate our error there. All right, guys, so that is the foundation for our networking layer here. Obviously, we haven't implemented our fetch products function to hook up to our API just yet, but this is how I always architect my services, as I'm sure you guys know. And the reason for this is because it doesn't tightly couple your view model to a concrete implementation of your service. A lot of times what I'll see people do is something like let service, and you just go here and say equal product service. This doesn't really accomplish much for you. So what we're going to do is make sure that we inject this service into our protocol so that at initialization time, we can choose which service we want to inject. And this will ultimately help with things like unit testing, or if you have different services that your application uses, maybe one uses Firebase, maybe you want to swap over to Supabase one day. It's just way better to have protocol-oriented service injection here and follow those solid principles. So let's go ahead and refactor our code into some new files really quickly. Let's just go into our products folder, and we're going to create a service folder, and we are going to grab just this guy right here, and we're going to go and paste it there. And then we're going to come back to this. We're going to delete this. We're going to grab the rest of these and bring it back to our product service here. And I like to put the protocol up at the top. All right, so this is what your product service should look like. Now, if we try to build our code, you guys will notice that we're going to get an error, and it's because we now need to inject this service into our view model. We are creating this view model from our products view. So now we need to say service, and we're just going to say, let's use our mock product service, right? Because we're just working with mock data for now. This is also extremely helpful in previews, guys, if you don't want to be reaching out to your actual production API. So now you can see that everything works as expected, right? We're just still loading and displaying this mock list of products. So what we're going to do next is get started with our actual API implementation. So let's go ahead and get started. But before we do that, I just want to make a quick note that I know I really blitzed through that whole concept. And if that's at all confusing to you guys, I highly recommend taking the original version of the networking masterclass before you take this advanced networking course. We're going to get into way more advanced topics than things like dependency injection and protocol-oriented services. So we are going to be sort of glossing over these concepts because I assume that you already have knowledge and understanding of them. So with that being said, guys, let's go ahead and get started with building out our API. Or our API implementation. So the first thing we're going to do is create our base URL, and it's going to look like this. It's going to be of type URL, and this is our URL string. So api.escuela.js.co/api/v1. And we actually need to go here and import foundation up at the top. And we are just force unwrapping this. This URL construction should never fail. If you guys wanted to safely unwrap that, you are more than welcome to. But we're just getting started with the implementation here to get the basics down, so we can come back to that later. And before we go into our fetch products implementation, guys, in our base URL, actually go ahead and add /products after your v1. And then our fetch products function is just going to look like this for now. We're going to say let data response equal try await URL session.share.data from our base URL. Return the decoded data as a product array from our data type there. So you guys are probably like, dude, I signed up for an advanced networking course. This is ABC 123. What the heck are we doing? And don't worry, we are going to slowly refactor this code step by step to turn it into a production ready networking layer. We are just starting with the basics as a refresher. So with that said, let's go ahead and hop into our products view, and we are going to replace our mock product service with our production product service, we could call it, or our service that actually talks to our API. And we should see a bunch of products coming back here from our actual API now. And this is looking great. So we have a working application already where we can communicate with this open API that we're using, and we can switch between our product service and our mock product service seamlessly because of the way that our code is architected. So that's a great starting point, right? But it's still pretty basic. So what do we want to start introducing next? So in our product service, guys, one of the first things we notice is that our response was never used. So we have no HTTP response handling here. So next up, we are going to implement some simple response handling here. And the reason I'm just copy and pasting some of this code, guys, is because once again, I understand these are pretty basic concepts, and you can reference the completed source code for this if you guys don't feel like typing this out. Once again, this is serving mainly as a refresher. So I want us to build this networking layer out step by step so that we understand everything every step of the way as we go through this process, because this stuff is going to get pretty advanced, and making sure we have a solid footing in the basics is crucial before we continue into the more advanced stuff. So right now, we now have our HTTP response handling implemented. We're just making sure that we can cast it as an HTTP URL response. If not, we throw an error. And then we're making sure that the response gives us back that OK status. It's in the 200s, right? And then if that fails, we know that we got a bad server response. And then if it's all good to go, we can continue on with our JSON decoding of our data type from the API response. So now we're just going to go back to our products view, and we can see here that we didn't break anything. Everything is looking good. And that's actually going to wrap it up for this video, guys. And in the next one, we are going to be moving on to CRUD operations for our products. So creating, updating, and deleting products. That was something that was not covered in the original networking masterclass. And that is a very important concept when working with APIs. You need to be able to create, update, and delete data, not just read data. And the main reason for that, guys, was because I just couldn't find an open API that supported CRUD operations, but luckily this one does. So we're going to be getting started with that next. Get excited. We'll see you there. Peace. What's going on, guys? Welcome back. In our last video, we created our product service and implemented it so that we can fetch products from our fake store API. In this video, we are going to be going over how to create products using our API. So if you guys didn't download the completed source code from the last lecture, make sure you go do that now. There was a starter package and a completion package. The completed source code package has some extra goodies in there with this product form sheet included. So we have this Boolean property to launch our sheet. We now have this sheet modifier that launches our product form view with this intent of creation. We can cover this intent concept later. It then sets our view model on the environment so that we can ultimately create products. So let's take a look at this product form view really quickly. It's pretty simple. Once again, it's just a simple form with all of the input fields we need for creating our our product. Here are all the properties we need to actually create a product. Here's this intent. And we can take a look at this really quickly as well. That's now in the model section. We are going to reuse this form to either create a product or update a product. I will cover this in more detail when we get to the update product section. Back to this form view. Once again, we just have this form right here. We have some error handling as well. So in our action button, guys, when we try to create a product in this submit function, we run some guard checks to make sure that all of the necessary data that's required is there. If not, we populate this validation message so the user can see, hey, you need to enter this data in order to actually create this product. And then we do a switch on our intent. So if we're in the create intent, which is what we're going to be starting with, we create our product here. We will then move into updating our product when we get to the update section. And when we get to the update section as well, when we launch this sheet, this is how we populate the form with product data for the product that we will be updating. So back in our products view, once again, we just launched that sheet from here, and you guys should have this functioning as you see in my preview. So the next step is going to be going to our product service and actually implementing the functionality to create a product or send that request to our API so that it creates a product for us. So let's get started with that. In our protocol, we're going to add a function called create product. We're not going to have any inputs yet. We're just going to say async throws product. So here, let's just go ahead and implement them in both of our services. We can say apply. And here we'll go and copy and paste this into our mock product service. And guys, the next thing we need to do is go over the input parameters that we need. But first, we want our compiler not to yell at us. So we're just going to say return product.mockproducts.first. And we can force unwrap just because we don't want our compiler yelling at us, right? Okay. So what does our create product request need to look like? So typically what I'll see a lot of people do is just add a million input parameters to this create product function. That gets really messy. So what we're going to do is in our models folder, we're going to create a file for all of our product payloads. So in this models folder, before we do anything else, let's create a new file, Swift file, and we're going to call this product payloads. So anytime we need to have some sort of request that gets sent up to our API, like a creation request or an update request, we're just going to put all those in this file. So this is what the create product request is going to look like. I'm just going to copy and paste it here. Simply a structure representing the payload that we need to send up to our API in order to create a product. So if you're wondering how we know what to pass up, that is going to be in the API documentation. So if you open up your API documentation here, we can go to our products and we can see here that if we go to create a product, we can see that we need to pass up a request body. So this is what our body needs to look like: title, price, description, category, and ID and images. And also note the response that we get back here, guys. This is going to return us the updated product that was created by our API. So that's how we know how to structure our create product function. We are going to ultimately pass in this payload and it's going to return a new product to us. So let's go ahead and pass that payload in. And that's going to be our create product request. We can copy this input parameter and paste it into each one of our functions in our services. So if we try to build our project, we should be good to go. Oops, I pasted it into the wrong one there. That needs to go into create product. Let's go ahead and hit Command B to make sure our code successfully builds. And going back to that product payload, guys, if you don't feel like typing that out, you can access the completed source code of this lecture in the resources section of this lecture. So there's going to be one for each lecture so that if there's a bunch of stuff you guys don't feel like typing out, you can just reference it in the completed source code. So next up, guys, we're going to go to our view model and we are going to implement this function. So I'm going to go ahead and create a function called create product. We need to payload here. And this is going to be our create product request. It's going to be async. And we're going to wrap this in a do catch block. And we are then going to say try or let product, actually we could say let new product equal try await service dot create product, and we'll pass along that payload. And here we can just copy and paste our error statement and change it to failed to create product with error, right? So now our view model is good to go. We just need to implement this function inside of our service, and then we need to go to our product form view and implement the product creation here by calling our view model function. So in our product service, guys, let's go ahead and figure out what we got to do to send this payload request up to our API so that we can create a new product. So first off, let's grab this and put it above our fetch products function. I like to keep constants up at the top of the file. So what we need to do, guys, is start building out a URL request. So in our fetch products function, we don't actually build out a URL request because we're performing a simple get request, right? So we can just get this data from this URL. But that's not how a post request works. So if we go back to our API documentation, we can see that this is a post request. This was a simple get request, right? You're just getting products. So we're going to start this off by creating a URL request. We're going to say var request equals URL request, and we're going to pass in our base URL. It's reaching out to the same products endpoint here. So the next thing we're going to do is say request.http method is equal to post. So our API needs to know that we're trying to post something to it. We're not getting something from it. So next up, guys, we need to encode our body payload into a JSON body. So we're going to say let body, let me get on a new line here, let body equal try JSON encoder dot encode our payload. And then we're going to say request dot HTTP body is equal to that body, right? And then we also need to let the API know what type of content type we're passing up. So we are going to be passing up JSON. So basically what we do there is say request.setValue, and this is going to be content-type, and HTTP header field is going to be application/JSON. So this is how it knows what type of content we're passing up to it. And now we can perform a request execution by doing this. The autocomplete filled that out nicely for us, or smart code completion, whatever you want to call it. And it also did our response handling as well. So I believe this needs to be 4. And now we are going to say let data response equal try wait URL session.share.data for this request. We're going to look at our response the same way we did in our fetch products function. We're going to make sure it's in the 200s and it's successfully casted as an HTTP URL response. And then next up, we need to return the response that we get back from our API request. So here we're going to replace this line of code with return try JSON decoder.decode. And this is going to be a single product .self from our data. And if we hit Command B to build our code, everything should succeed. And this is how you perform a post request, guys. Obviously, we are going to be refactoring this and cleaning it up. Right now, we see that we have quite a bit of duplicated code in our 2 functions, right? Our response handling is the exact same in our fetch products as it is in our create product. So that's a red flag there. And we also are passing in a raw string for this HTTP method. We're eventually going to create an enum for this. But what I want us to do is go ahead and just test out this basic version first to ensure that this is working. Implement this in the product form view. I just want us to go and add a print statement to our view model. So let's go here and say print new product, and we'll just interpolate that. And then what we're going to do is insert this new product into our products array, guys. So we're going to say products.insert new element, new product at 0. So it gets added straight to the top. So now that we have that, we'll get a print statement back. We should see the product immediately populating into our list. Next up in our product form view, we need to go and implement this create product functionality. So what we're going to need to do is create the payload from here and pass that along to our view model. The view model will then call that service function that's responsible for sending that request up to the API to actually create the product. So we're going to say let payload equal create product request. I'm going to highlight this and hit Control M to make it cleaner. And we're going to say title. We'll say parsed price. We have that up here in our validation checks. We try to parse the price as an integer. Then we'll go down here. We'll say description, or product description rather. Here we'll say parsed category ID. And here we will say we're going to just add a single image URL. So we're going to say image URL right there. And this is pre-populated with just something from the Pixum API. Guys, this is just an open service that you can use to get free images. So we're just going to upload this image URL for that product. We're not going to go over any actual image selection or anything like that. So next up, we have our payload. Now we're just going to say await view model.create product and pass along our payload. So really quickly, guys, just to go down the chain of how this works in our view model, we go to create product. This is implemented in our product service protocol. So regardless of what service we are injecting into it, this is essentially taking an agnostic approach. So we don't know what the implementation is in our view model. That's left up to the service that we inject into the view model, which in this case is our production API. So it will just implement whatever version of this function that we pass in when we create this view model. That's the concept of this abstraction here. So then if we go to our service.createProduct, we'll see here that we have 3 different options to choose from. And we're going to go to our product service implementation. So this is what it will actually implement. If we were using our mock product service, it would simply do this. And it then goes through this chain or this sequence of, instructions. We create our request. It's a post method. We encode our body here, which makes just makes our life easier because we're using this structure for our payload. And we set our content type. We execute the request and we handle our response, and then we should get back our new product here. So that's just an overview of how this works. Now it's time to test it out. So let's go ahead and see if we can go to our products view. We can do this all from the preview, and just go ahead and get your preview up and running, and we'll launch that form and see if we can create a product. So let's hit this plus button and let's create a product. We're going to say test product app stuff. Price can be $99. Test product from app stuff. And let's hit create. And you guys will notice nothing happens, and we should be able to open up our console, and we're going to see that we failed to create this product with an error. It says the network connection was lost. We obviously have a network connection because we were able to fetch our products from our API. So something else is going wrong. So let's go back to our product service and see if we can figure it out. This is where error handling comes into play. We need to know what's going wrong so we can fix it, right? So one of the first things that I noticed was we have these values backwards. So we actually need to go here and say that this needs to be application JSON, and the HTTP header field is the content type. So we just had those mixed up. Let's make sure we don't have any typos here. Content type. Okay, that looks good. Now, guys, what we're going to want to do next is we could add some print statements to our response handling here. Right now, we're just throwing an error, and it's just giving us back this bad server response. That's a very generic error and doesn't really tell us what went wrong. So we're going to implement some print statements here to get a more descriptive error message so we can figure out what to fix. So let's go ahead and highlight this section here, lines 34 to 36 for me, and we're going to paste in this new code here. So we're just going to make sure, we're going to parse the status a little bit differently, or just make sure that it contains that numerical value. And then we're going to look at this body string, and we are going to compose a string from the data that comes back, and we're going to use the UTF-8 encoding, and we're going to say print create failed with the status code and that particular error. So this is eventually going to go into like an actual network log for us guys, but for now we're just going to use print statements. So let's go back to our products view, and we can try this one more time. And once again, this stresses the importance of having a robust error handling API in your networking layer, which we currently do not. So here we're going to say test product app stuff, price 99, test description, and let's create. And guys, if you pull your console up and make sure you have Canvas selected, executable is for the simulator, Canvas is the console output for your preview, we can see here that we actually got our new product successfully created. So we're not running into errors anymore. And if we were to dismiss this, we see our product showing up right here at the top beautifully. So that worked. The only thing I want us to do is inside of this product form view, we should execute a dismissal on success, right? So here we're just going to say dismiss. And we will come back to this and implement an extensive error handling API, guys. Obviously, we'd like show an alert if something went wrong. We would not dismiss the screen, let the user know what went wrong, and a user-friendly error message, so on and so forth. But the big takeaway here is that our product create request successfully went through. It created a product in our API and returned that product to us in a response, and we were able to append that or insert it into our list. So the only thing we had to do was flip-flop these values. We had them mixed up. You guys might have caught that before I did, but I'll just go through this one more time, guys. The difference between these two things is pretty big in that we have to create and configure a URL request in this product creation function. Here, we're just pulling data from this URL, so it automatically configures like a GET request. I'm sure that there's some sort of something going on under the hood in this function that's part of URL session if you're just pulling data from a URL. But here, we have to set our HTTP method. Right now, this is a raw string, so we're going to refactor this into an enum. We then encode our JSON body. We set up the content type that we are going to be passing up in our request, so the API knows what it's about to accept in the payload. And then we go and fetch our data here or execute our request. We get back our data in response. We handle our response validation in these two guard statements here. We added some print statements to give us a better idea of what was going wrong if and when that happens with this response status code and this body string that comes back in the error block. And if all of that happens successfully, we then get a response back from our API with that newly created product, which we were then able to display in our list by saying let new product equal the result or response of this product creation function. We printed that out here and then we inserted it at the top of the list. So that's going to wrap it up for this one, guys. In the next one, we're going to be going over how to update products. And we are going to see that it's going to involve a lot of code duplication and violates that DRY or don't repeat yourself principle, which is going to be an automatic trigger for us to start refactoring our code and to build a more generic and reusable networking layer in order to accomplish that. So we'll see you guys there. Peace. What's going on, guys? Welcome back. In our last video, we went over how to send a create product request to our API. And ultimately that led to us creating a product and getting a response back with the newly created product so that we could update our UI. In this video, we are going to get started with going over how to update a product. So the first thing we're going to do is head over to the API documentation to see what exactly it is we have to do to execute an update product request. So I'm going to go ahead and get the docs opened up, and I've scrolled down to the update a product section. So we can see here we need to send an object like the following and add the ID as a parameter. So we are going to need to modify our base URL here and specify the product ID that we want to modify. This is going to be a put request, and here is the request body that we need to send up. And here is the response we get back. Once again, this is just going to return us with the updated product. So the first thing that we are going to do is hop back into the code. And before we create our function, we need to create our payload model. So if we go back to the documentation really quickly, we can see that we're just passing up the title and the price. That's the only thing the API allows us to update. So it's going to be a pretty simple request body. So in our product payloads, let's go ahead and create a new struct called update product request. It's going to be encodable. And we're just going to have a title and a price. And I believe the prices are integer values. So now that we have that, we can go back to our product service and we're going to update our interface or our protocol here. So func update product with an ID, which is an integer. We do need the ID, and we're going to say with our payload, which is our update product request. And this is going to async throws a product. And guys, while we're at it, we could just make the deletion function as well. And it's going to look just like this. We just need to pass in an ID of the product that we want to delete. And let's go ahead and implement these functions. So let's have update right under here. So actually, let's do it at the very top just so it's easier for us to read and access. We're going to say update product. And then here we'll say delete product. And to start things off, we're just going to say return product.mockProducts.first. And here we don't need to do anything. And let's copy these two functions, scroll down to our mock service and add them here as well so we don't get compiler errors. Okay. So that looks good. So what's our update product function going to look like? We can just go ahead and implement that now. Well, what we're going to do is basically copy and paste all this code. And yes, I know that's a huge red flag, but don't worry. We are going to go over a refactor shortly after we implement this update functionality. So let's go ahead and paste that in here. We're just going to modify this to put. And the interesting part here, guys, is we actually need to modify our base URL. So we would actually need to create another URL here because we don't actually have the ability to modify this guy. So that's another weak point in our current networking architecture that we're going to resolve when we go through a full refactor of this. So let's go ahead and just say let base URL be of type. We can just copy and paste this. And we need to interpolate our product ID. Oops, ID. We could maybe use this as a variable and modify it here by like appending this ID, but it doesn't really matter because we're going to redo this stuff later anyway. So the only real difference here is that this is a put request. We are simply going to encode the payload as we did in our create function. This is just a different payload. We encode it. We set our header or HTTP header field to accept JSON. We get our response. After we execute that request, we go through it and make sure that we get, a OK status HTTP response, and then we return the updated product here. So now we can come back to this delete function later. Let's go back to our products view model and implement this function. So we're going to go ahead and create an update product function, ID, which is an integer with payload, update product request, async. And this one's going to be a little different because we need to find the product index in our products array and update that product with the new value. So we'll do that in a sec. For now, we'll just say do and catch. And it's going to be pretty much the same as what we had here. We can actually just copy this. And instead of create product, it's just going to be update product. And we need to pass along that ID and pass in our payload here and clean that up. And here we can call this updated product. And we are not going to be inserting this product here, right? So what we're going to do is find the product in our array via this ID. And then we are going to update it after we complete our API request. So we're going to say guard let index equal products dot first index where, or not first, I like to use first index. And we're going to use our brackets here. And we're going to say 0.id is equal to the ID we're passing in this function, else return. So if we can't find the product in the array, we just stop. Ideally, we'd throw some sort of error to say like product not found, but we can get to that when we implement our error handling API. And now, guys, we are going to go here and say products index equals new product. And that's all we have to do for our update product request. The next thing we need to do is figure out how to actually trigger the update function. So if we go to our product form view, this is where this intent comes into play. So we're going to be reusing this view for both creation and updates. It doesn't make sense to have two separate views for that, simply because basically everything is the same. In this case, we can't update things like the description or the category ID or the images and stuff. So you could argue that you could create a separate form or adjust the form based on the intent, but we don't really need to bother with that. We just need to know that we need to live here. This is where we need to call our function. So we're going to go here and say let payload equal update product request. And we'll say title and our parsed price. And then we are just going to say await view model.update product. And it's going to be our product.id with our payload. And we get this access to this product via this associated value from our enum case. So let's go ahead and take a look at this intent really quickly. This is a really cool or neat architecture pattern that I use involving CRUD operations for almost any app that I build. Whenever there's a creation screen, you also have an edit functionality attached to that usually. So I always create this intent. And when you launch that screen, you initialize it with your intent. Are you creating something or are you updating something? Okay, if you're updating something, what is it? In this case, it's a product. So we pass along the product that we are updating in this as an associated value when we inject our form with this update case. And here is our navigation title associated with the intent and our submit title associated with the intent. So now let's make the rubber meet the road and let's go to our product detail view and let's see where we actually launch this edit form. So we have this Boolean parameter here to manage our form presentation. And if we go down, we actually don't have a sheet for this yet. So let's create it and see how exactly we can use this intent. So we're going to say .sheet is presented. And we actually, guys, I think we're going to do this a little differently because we need to select a product, right? Oh, we actually initialize this with a product. So that works out perfectly. So we'll say .sheet is presented, $ is showing edit form. Our content is going to be our product form view. And here we pass the intent as update, and you'll see now it asks us for a product. And we are going to pass in the product that we initialize this product detail view with. So we're updating this product. When we launch that form view, it will populate the form with all of the data from that product, and ultimately we'll be able to edit that particular product. Let me just clean this up a little bit here. I don't like that content parameter. It just looks cleaner like this. So now we look good. So let's go back to our products view and go to our product detail view and see if we can launch that update sheet. So I'll click on this first item here, our majestic mountain graphic t-shirt. We'll hit edit and we actually get a crash, and I'm assuming that's because we don't have our view model set up on the environment. So let's go back to our product detail view, and we are probably going to need to add our view model to the environment right here. You guys will notice we don't have it here. So we're going to need to say at environment product view model .self private var view model. And when we launch this sheet, we are also going to need to set that on the environment. And I believe we're going to need to set it on this product detail view as well, because that is initialized as a state property here and is not configured on the environment yet. So we just need to go here and also add that as an environment property to the view model, or sorry, on the product detail view. So we could initialize this one layer back, like in the content view or at the root app level, and set it up on the environment here so we don't have to do that. But we will come back to that architecture later. That's more of a Swift UI nuance. So guys, now if we relaunch our preview, we should now be able to successfully launch that edit sheet. And we see here that we're good to go. And all of our product information gets updated here, or populated here, sorry. And really quickly, guys, that works because in our product form view, we have this function down here at the bottom, populate form if needed, and it takes a look at the intent here, and that's how we get access to the product data. And then we just configure all of the fields or the input fields with the product data here. So that's just a quick explanation as to how that works. Let's go ahead and now test our product request out. So let's just update the price to be like $28. Seems better for this kind of t-shirt. I wouldn't pay 44 bucks for that. Let's hit save and let's pull our console up to see what happened, and make sure we're on the canvas console. And it's looking like create failed. Let's go ahead and take a look at our error messages. We see new product here. So let's go ahead and look at our logs really quickly, guys. So in our product service, yeah, so we need to actually change this to update failed. And as a heads up, I don't think the API for this is actually working. You guys noticed that we got an internal server error. So that means we're not doing anything wrong. Something went wrong on the backend side of things. That's what a 500 status code means. So it looks like they just have a bug on the backend side of things. But essentially, that's how we would execute an update request. Really just wanted to get some repetitions in there as to how we can create custom URL requests and configure them accordingly to what we're trying to do. In this case, we're trying to update something. So this is a put request. We created a separate payload model. And this is typically the pattern you're going to follow when you are performing CRUD operations within an application, guys. You have some UI attached to your form update. We have that slick implementation with our intent there. And then executing the request is pretty straightforward. So what I want us to do next is go back into our product service and finish out our implementation with this delete product function. And then in the next video, we're going to talk about all the reasons that this is a suboptimal architecture for our networking layer. We have no real reusability. We're repeating a bunch of code everywhere, and this really just isn't a scalable approach. So let's just continue on in this suboptimal way for this delete product implementation, and then we'll go over how to refactor all of this stuff in the next video. So guys, we're just going to once again copy and paste a bunch of code, and this URL here is going to be the same. Let's just double check our API so that we can see how to delete a product. And yep, we just need to pass along the product ID, and this is a delete HTTP method. So here we're going to type out delete. We don't have to pass up a body. So that means that we don't have to set any sort of value because we're just deleting something. And then we simply just execute our delete requests and we don't return anything. This is a void response type. So our deletion is a little bit simpler, but we're still copy and pasting this response handler or validation code exactly from the other three functions, which is no good. So really quickly, let's just go into our view model and implement this here as well. Delete product ID, which is an integer, async, do catch. And guys, let's update this error message in the update product function to fail to update product with error. Here we can copy and paste that to failed to delete product with error. And we are just going to say try await service.delete product with that ID. We're going to need this index functionality here as well. And then we're going to say products.remove at that index. So our CRUD layer is now complete. Now, like I said, the implementation isn't great. Let's hop over to ChatGPT and ask it to rate our implementation for us. I already did that. So in the ChatGPT window, I simply said, rate this service implementation out of 10. I think ChatGPT was being a little generous here, and it gave it a 7.5. Told us what we're doing well. We have protocol-driven design, async await usage, basic error handling with some print statements, consistent JSON encoding / decoding, and debugging hints with our print statements. What could be improved? We implemented this method, so we're good there. We have no error handling. We have really poor base URL handling. We can see here that we're just, we have it as a class level property up at the top here, but then for functions that need to modify that, we just recreate it. That's no good. And our request configuration duplication, that we are basically creating a URL request and just copy and pasting that across functions. The only real difference here is the HTTP method and whether we need a body or not. We do have some mock behavior, so that's good. And our logging and printing, that's also not considered best practice to do, guys. You only want to execute print statements and stuff if you're in debug mode. You don't want to do that in a production release. So it gave us some suggestion improvements with making a reusable request helper, implementing an API error enum, and all of that stuff. And that's what we're going to be getting into in the next video. So once again, guys, this, as we can see, isn't bad, but it's a far cry from being a professional, production-ready, scalable approach to networking. So imagine if you had to, I think I've mentioned this before, but implement a user service here. We would just be building technical debt by copy and pasting all of this stuff when there is a lot of reusability we could extract and share between product service, or not product services, just services in general. So we're going to be implementing like 3 other features in this application. So we're going to want to make a reusable request builder, networking layer, and all that stuff. So that's what we're going to be getting into in the next couple of videos. We'll see you guys there. Peace. What's going on, guys? Welcome back. In our last video, we implemented our update and delete methods in our product service. And in this video, I want us to get started with refactoring our code a bit here to make more of a reusable API request helper to start things out. So once again, we covered this at the end of the last video, but we can see here that we have a ton of repeated code between these 4 functions when it comes to building out our URL request. So that immediately jumps out to me. that we could make a request helper or builder that we could then implement in each of these functions to build out and configure our URL requests. So that's going to be the first step in many of the refactors that we make to make this more of a reusable and scalable networking layer. So in this networking folder, we're going to go and create a subfolder, and we're going to call this requests. And we are going to make a new file, and we're going to call this API request. So this is just going to be a struct that we build out that helps us build and configure URL requests. So we're going to import foundation. We're going to create a struct called API request. And we are going to start off by implementing a generic here, guys. So we're going to create this response type, which is going to be some decodable object. So this way we can specify the type of response that we're getting back when we build this API request. And it will be generic, so it can decode any sort of data type that we pass into it. It could be products, it could be users, it could be crypto coins, whatever. We definitely want to make use of that generic type here. So the next thing we're going to do before we add any more properties is create an enum for our HTTP method. And this is going to be a string. We're going to have case for get, and it's going to be get, case post equals post, case put equals put, and case delete equals, you guessed it, delete. So it's just better to have a structured type here to specify our request types. Instead of typing these raw strings out every time, we could misspell something and that could completely break our networking request, right? So now we have an enum type to specify our HTTP method. And the first product or parameter we're going to introduce here is our HTTP method. And then guys, we're going to have our path, and this is just going to be a string for now. So this is going to be the endpoint URL essentially. And then we're going to pass in some data for our headers, which is going to be a string dictionary type, string key and string value. We're going to have an optional data type that we pass in for our JSON body when we need to upload or execute post requests and update requests, or put requests rather. And that's going to be it for now. So next up, let's go ahead and create an initializer here. And next, guys, we are going to introduce a method here that is going to be responsible for building our URL request. So we're going to call it make URL request. And we are going to look at a base URL, which is a URL type. And we are going to have some default headers here as well. And this is going to come into play later when we have to pass additional data into headers, guys, like refresh tokens, access tokens, API keys, and things of that nature. And that's going to be it for now. And this is just going to be a throwing function, and it's going to return a URL request. So the tie-in here is that inside of our product service, we are going to use this make URL request helper to build out our URL request for each one of our functions. And we'll be able to specify the method that we want, the path that we want, the headers that it needs, and the optional JSON body that it needs as well for the request. So the first thing we're going to do in this request builder is build out some URL components that we can modify. So I'm going to say guard var components is equal to URL components. And we're going to use this option here, URL and resolving against base URL. So this creates a URL components instance from a URL string, optionally resolving against a base URL. So that's pretty much exactly what we're going to do. We are going to say base URL dot appending path component, which is the path that we pass in here. So an example of this would be the base URL is our fake store API. And then our path is going to be /products or /product/ID, right? So let me actually highlight this and hit Control M to clean that up. And then guys, if that fails, we can simply throw a URL error. So we're going to say throw URL error dot bad URL. Okay, so we have our components, right? So next up, guys, Here, we're going to also introduce some query items. We don't currently make use of this yet in our products API, but we will need to do this later. So we are actually going to add an input parameter here. So let's go up, and underneath our path, we're going to say var query items. And this is going to be an array of URL query items. And then here, we also need to implement that in our initializer. So we're going to say query items, URL query item, and we will default it to a blank array. And guys, let's actually highlight this and hit Control M as well. This is getting a little messy. We also want to default our headers to just be a blank dictionary because we don't always need headers in our request. And now this is looking good. So we just need to say self.query items is equal to our query items. So next up, in our components, we are going to add those query items to our component builder. So we're going to say if query items.is empty, or if it's not empty, rather, we're going to say components.query items equals our query items. So if you are unfamiliar with what query items are, don't worry, we will cover this when we actually need them. So next up, guys, we're going to say guard let URL equal components.url else. And we're just going to throw this error here. So we're no longer force unwrapping things. And now it's time to create and build our request. So we're going to say var request equals URL request with this URL. You guys will also notice we have things like timeout intervals and stuff like that that we could configure or add as input parameters to this API request model. We're not going to worry about that for now. And then we're going to say request.http method is equal to our method.raw value. So we never have to worry about typos here. It's being configured from the enum. And then we're going to say var merged headers is equal to our default headers. And then we're just going to say, one sec, merged headers. And we're going to say merged headers dot merge. This is a built-in helper. And we are just going to say this right here. So this will take our default headers and just merge them with whatever additional headers we pass into this function. Once again, we aren't really doing anything with this right now. Actually, we are when it comes to post and put requests. So we'll see how this works out in a little bit. And then we're going to say request.http body is equal to our body. And then we're going to say request.all HTTP header fields is equal to our merged headers. Let's actually do this here. And then we're going to return our request. And before we move forward with implementing this, guys, I actually want us to create one more initializer method, and I'll explain the difference between the two, and we'll see how they're used when we implement this API request model in our product service. So we're going to initialize this one, but we're going to initialize it with some generic encodable type called body. And then we are pretty much just going to grab all of these properties here, and it will be used almost the exact same way. The only difference is passing in this encodable type. And we're also going to pass along an encoder here if we need custom encoding rules. So we're going to say JSON encoder, and we'll give it a default value of the default JSON encoder. And then we're just going to add a comma. And you guys will notice we're getting an error here. We're going to fix that in a second. The first thing we need to do is make this a throwing initializer. And instead of just saying self.body equals body here, we're actually going to remove this as a data type, and we're going to pass it along as our generic body. And we are going to not make it optional here. And then here, we actually need to encode that. So we're going to say try encoder.encode our body. And then we are going to add a convenience block here, guys, of adding or setting up our headers right away, so that we don't have to do this per request. It's already handled in the initialization. So we're going to say if self.headers content type is equal to nil. So if we don't pass along headers that specify the content type, we're just going to take care of it here. And we know that we are going to be uploading some sort of JSON body to our API in our request, so we can handle the header construction here. So why are we creating two initialization methods? Well, not every URL request has a body that needs to be encoded to pass up in that request, right? For example, a GET request doesn't require passing up a body. Neither does a delete request. We only need that for put and post requests. So this acts sort of as a convenience initializer when our URL request is going to have to pass up some sort of JSON body or some sort of encodable type, as we see here. And this will be used for methods that don't, right? So that is our API request model for now, guys. What we're going to do is now go into our product service and see how we can reuse this across each one of our functions to make a significantly cleaner networking layer here in our service implementation. So we are going to start with our update product function. So let's just go ahead and start by deleting all of this code here. So we'll be able to replace this with our request builder. So let's go ahead and create our request. We're going to say let request, and we're going to say equal our API request. And guys, we are going to be able to specify the response type in our API request initializer. So we know that we want to, or we get back a product as a response. So we're going to specify that when we initialize this API request here with our generic type. And then we're going to say that we want to initialize this with a method. And we have to think about which initializer we're going to use here. So we have this method here that asks us or requires a body, which is an encodable type, and that's what our payload is here. So we can pass that payload along, and it will automatically encode that and set up our headers accordingly. So our method, guys, is going to be .put. Our path is going to be, we already have the product's URL up here in our base URL, so we just need to append our ID. And then our body is going to be our payload. And you'll notice that call can throw, but it's not marked with try. So this was a throwing initializer. So we need to say try here. And we could call this like request model. And then we could say let request equal request model dot make URL request with that base URL. And our default headers, we actually don't need that. We need to give this a default value because this already configures our headers. So let's go ahead here and replace and just set this equal to a default value. And we should be good. Now we can go back here and just delete this. And that's how we build our request. And I think we also need to say try here. And everything else will function accordingly. So we can see how much of this we have already cleaned up, right? So the next step in this cleanup process will be to extract this into like a response validator. Well, we can handle that later. Let's go ahead and see if we can implement our request model in the rest of these functions. So guys, in our delete function, we can now delete these 3 lines of code, and let's go ahead and build out our request. So we're going to say let request equal API request. And here's where things get interesting. We don't exactly have a response type here. So we have a couple options. We could choose to return a Boolean variable and return true if the request completes successfully, or we could build out an empty response type. So let's actually pause here. Let's actually just delete this code. And let's go back to our API request. And what I want us to do is just add a structure up at the top. And we'll call this struct empty response. And it'll just be encodable. And it'll just be a blank structure. It's literally a blank response, right? So what we could then do, or sorry, let's make it decodable. That's my bad. So now when we build this API request, we can just specify that it's an empty response. A delete doesn't give us anything back. So let's go ahead and go back to our product service. Now let's build out this request. We could say let request equal API request. And here we could just say empty response. And our method is going to be .delete, and our path is going to be ID. Just like that. It's going to just add that to our base URL. And then we'll say, let's actually call this let request model. And then we can say let request equal our request, or try request model dot make URL request with our base URL. And then we continue on with executing that request and validating our HTTP response. And if nothing goes wrong, no errors get thrown, and this function completes successfully. Like I said, guys, the other option would be to return a Boolean variable, and then you could specify this as a Boolean type. And then, you could say that if the request completes successfully, you just return true. If not, you return false. It's really up to you with what you want to do there. I personally prefer the empty response type. So let's continue on with our remaining two functions. We can go ahead into create product request. We could delete all this code. And this is going to be really similar to our update product request. So we can just copy and paste these 2 lines of code here. Our method just changes to post. This actually doesn't have to specify or append any sort of path. So we can just pass this along as a blank string. And our body is going to be this payload here. And that's all we need to do. And finally, we weren't even using a request build for this fetch products guy. We were simply just fetching it from our URL and using this separate function on URL session to do that. But we want to stay consistent with our architecture here. So let's just go ahead and build that out as well. So guys, we're going to say this is actually going to be similar to the delete. So we can go ahead here, grab that. And this is going to be a get request. And we also don't need a path. And then we just build out our request as so. And we are actually going to go here and say, let data response equal try-await URL session.share.data for that request. So really quickly, a modification I want to make, guys, is in our base URL, we typically wouldn't append this products path to it, right? Because this is the actual base URL of our API. It's not with like products here. So when we create additional services, we would probably have this base URL in a separate like URL factory or enum or something like that. And we would specify that it has this products path attached to it. So let's actually delete products there just to make sure that we are doing this the right way. And here, this would be products/ID. And then this down here would be products/ID. And we are going to make like an API requests or path model for this in a little bit. I just wanted to show you guys how this works to start. So now this would not be a blank string. This would just reach out to our products endpoint. And this would also reach out to our products endpoint. Okay, so this looks good. Let's go ahead and just head back to our products view and see if we're still fetching our products correctly and if everything is working as expected with our new request model there. Okay, so it looks like we are successfully fetching our products. Let's see if we can execute a product creation request. Let's say test product with new model, 99, test, and let's hit create. And if it dismisses, we know that we're good to go. Let's go to our Canvas console and we see that we created a new product here. So our refactor is successful and we're looking good, guys. But we're not done yet. So we're going to go back to our product service, guys. And one of the big remaining red flags we have here is our duplicated code for this response validation. So we're going to build out a helper to help us validate those responses. But that helper isn't only going to be responsible for that. We also notice that we have some duplicated code when it comes to executing our request and in addition, handling the response and then ultimately decoding our data, right? So we can make a helper to handle all of that stuff for us. All it needs to take in is a request model. And then the helper will be in charge of building the request, executing it, handling the response, and returning the response type. So in this case, it's a product. In this case, it's an empty response, so on and so forth. So let's go down here and start building out this helper. We're going to call it execute. So private func execute. We need to introduce a generic here because we could return any type of response. It could be a product or an empty response. We're going to pass in our request model, which is our API request. And we're going to say async throws that response. So we notice, guys, that we also need to specify the generic type in our API request. This will just be our response type. Okay, so now we're going to take this request model and we're pretty much just going to copy and paste all this code here. So let's go ahead and grab all this stuff. We can cut that and paste it in here. So we're going to say that request equal try request model dot make URL request with our base URL. We execute the actual API call with that or for that request. We then handle our response, and then we return the type that we specify when we call this function. So it's going to be return try JSON decoder dot decode response dot self from our data, right? Perfect. So now we'll see how magical this helper becomes, because in our fetch products function, we simply build out that request and we say execute. And we're just going to pass along our request model. And I think we need to say try await. And we're actually going to say return try await. And this is not the right response type. That's my bad. This is actually going to be a product response, an array of products. We copy and pasted that from the delete method. So this is actually going to give us back these products here. All right. Next up, we're going to say return, try, await, execute our request model. Boom. No errors. We're good to go. Same thing here. Delete product, return, try, await, execute, request model. And okay, here this gets interesting. Unexpected oh yeah, we don't actually have to return anything, so we just say try, await, execute, request model. And here, because it does return an empty response, we could just say let underscore equal try, await, execute, request model. In this case, you might think it would make more sense to return a Boolean variable. Like I said, that's completely up to you guys. I typically prefer this empty response type because this lets me know when I create this API request that I'm going to have an empty response. So next up, guys, we just do our update guy and we just say return, try, await, execute on that request model. So look how much cleaner these functions got, man. That's like pretty crazy, right? They're literally just 2 lines of code each because of this helper that we built out. And we sort of killed 2 birds with 1 stone there. We now have our response validation centralized into a single function. And this function is also responsible for executing all of our requests and building the requests from that request model. And it supports this generic response type, so it can return any type of response. So down here at the bottom, we use our JSON decoder to decode the response that we specify at the time of this execution. And that's already handled because this Swift is smart enough to recognize that the API request model is built with that generic type. So when we call this execution function, it simply inherits from that and recognizes the generic that we are specifying at the time of building this API request. So that's pretty clean, man. This is looking really good. Let's head over to the ChatGPT to rate our new service implementation. So rate my service out of 10 again. This is something I routinely use ChatGPT for when I'm coding. I simply ask it to rate things for me, and it tells me what I'm doing well and what I could do better. So you guys will see that we've upgraded to a 9 out of 10. That's pretty solid, and we don't even have a robust error handling API in here, right? We're simply printing create failed, and this is not even supportive of like the different methods that we're using. So here we would just want to say like failed, or we could use the HTTP method that's attached to the request to get some sort of print statement there. But we're not going to bother with that because we need to introduce actual error handling later. We need to introduce the ability to display user error messages and developer focused error messages as well, so that we know what went wrong and where. But overall, guys, this is a significant improvement, and there's still a lot that we're going to be doing in terms of building out a fully generic and reusable networking layer. So this is just the beginning. We still need to implement things like caching, retry policies, network logging, network interceptors, and more. So get excited, guys. We're going to take this step by step and we're slowly going to work towards having that fully production ready networking layer that you can reuse in any one of your applications. So thanks for watching this one. I hope you guys are enjoying the course so far. We'll see you in the next one. Peace. What's going on, guys? Welcome back. In our last video, we did a pretty significant refactor of our product service to implement our API request model. And we also built out this execute helper to reduce each one of these functions down to 2 lines of code, which is pretty awesome. But there is one more thing that we need to refactor in our product service, and it's a weak point or vulnerability that we have here, which is these raw strings being passed along as our endpoint paths. So if we spell one of these things wrong, our entire request fails, and we might drive ourselves nuts trying to figure out why. So we want to structure this out into a path model. So here's how we're going to do that. We are first going to go into our products models folder, and we're going to create a new file, and we are going to create a Swift file, and this is going to be called product endpoint path. So we're going to just encapsulate all of the different potential paths we have into an enumeration so that we don't have to worry about typos, and it'll be centralized into a single component, which is overall just a better architecture with less vulnerability. So here, guys, we're going to create an enum, and we're going to call this product endpoint path. And we only have a couple paths here. So it's just going to be a case for listing our products and a case for by ID. And we're going to pass along an integer as an associated value that represents our product ID there. So then we're just going to create a path property. It's going to be a computed property, and we're just going to switch on our potential enum cases. So switch on self. Case.list is just going to be products, and case.byId, let ID, is going to be products / our ID. And that's it, right? So next up, guys, how do we want to implement this now in our product service? We have a couple different options. Here, we could go and say product endpoint path by ID and pass along our ID, right? And then we would have to say path, just like that. And we could do this for each one of our functions here. We would just go here and say the same thing in delete. So it would be like this, by ID. And this would just be product endpoint path.list. Product endpoint path.list.path. And it would be the same for fetching our products, right? So this is definitely not bad. We are now grabbing this path endpoint from an enumeration, and we now no longer have to worry about raw strings being passed into these functions. So we reduce the potential for typos to basically 0, and it's centralized into a single model. However, I think we could take this a step further. So right now, this path still accepts raw strings. So we don't know that we have this product endpoint path potentially, right? Like if we're coming into this code base and we don't look at all the models and stuff, we might just say, oh yeah, let's go to products / ID, right? So essentially what we have here is sort of an invisible vulnerability in our code. And what I mean by that is like we've created this endpoint path, but there's nothing enforcing its use, right? We could simply pass in an empty string here and hit Command B, and our code would still compile. So this is, like I said, sort of an invisible vulnerability. You might be like, oh, hey man, I created a model, I'm good. But then you get some developer that comes into your code base that doesn't know he has to use this, or you forget yourself, or you just have a typo or something, and your code builds, you're like, hey, I'm good to go. You ship it, and then it breaks in production, right? So how do we enforce at compile time stronger typing here, or the use of an the actual use of this model as opposed to a raw string? Well, we can go to our API request, and we can replace this input of a raw string with our product path. So we could say product endpoint path. And now we have to go here and say that that's a product endpoint path and that's a product endpoint path. And we are now going to get a value, an error here, and we're going to go here and just say path.path, which is that computed property that exists on that enum type. Go ahead and build. And once again, our code should build all the same. Let's see, product service. Oh yeah, now we don't even need to pass this path guy along because that is a raw string. And now guys, we don't even have to specify this enum type here because of the beautiful shorthand notation we get with Swift. So we could delete all of those and look how much cleaner our code becomes. And now we have that compile time enforcement here, or that stronger typing, in that if I go and pass in a raw string here, I say, list, it's going to say, hey, guess what? You can't do that now. You have to use this enum type. So I'm going to go here and be like, oh, okay, cool. I have to use that. And now I can go here and see exactly where it came from. And now we have full compile time enforcement with our typed data here, or using this actual model here. So there's one more problem with this, however. Now, if we go to our API request, this is now tightly coupled to our product endpoint path, right? So if we created a different service with a different set of endpoint paths, like a user service or a crypto service or whatever it may be, this would fail. So what do we do to resolve that? Well, what we can do is in our networking folder, guys, go ahead and create a new folder, and it's going to be for routing. So just go ahead and create a new folder here, routing, and we are going to create a new file, and we are going to call this API routes or API route. And we are going to then create an enum here with nested associated enum types. So we're going to say enum API route, and we're going to say case products, and we're going to pass along an associated value, or associated value. Sometimes I get mixed up between associated value and associated type. So this is an associated value, right? So now if we add routes to our project, we could say like case users, which we'll do eventually, then we would have like a user endpoint path, right? So now this acts as sort of a universal API route where we can pass along different paths in accordance with different cases. So we're going to go back to our API request model, and we're going to replace that with our API route. And then here, we'll go here and say API route. But we also need a computed path for this. So we're going to say var path, which is a string, switch self, and we're going to say case products, let product path, and we're going to say return product, or we could call this let product route rather. And we're going to say return product route dot path. And now in our request model, we have this path computed property that exists there. So we're good to go. So that might be a little confusing to wrap your head around. We'll definitely do a recap here really quickly. Let's just go ahead and go back to our products view, run our preview, and make sure that we are still successfully fetching our data. So this is where having unit tests really helps you out, guys. We are not, however, going to be implementing unit tests in this, let's see. Oh yeah, so here, now we need to change this up. We need to say .products, and then we need to say .by ID. And here, we're going to say the same thing. And here, we're going to say it's our products endpoint, and it's our list product path. And then here, it's going to be the same thing. So like I was saying, this is a really good time to have unit tests available to you so that when you make changes like that, you can simply run your tests and see what passes and what fails. But okay, so it looks like we're good here. And luckily for us, our app is simple enough where we can just test it ourselves right now. But as your app grows in complexity, unit testing saves you a ton of time. That is why I built a full test-driven development course. You guys can check that out on the website. It covers all things testing in iOS. So we cover the foundations of test-driven development with simple app testing with unit and UI testing. We do network tests with a real crypto app, advanced UI testing with a full onboarding flow. We also do CI and CD integration with Xcode, GitHub Actions, and Fastlane. And then we do performance testing and profiling with Xcode Instruments. So we actually profile the performance of our SwiftUI apps. And we also introduce performance testing as well. So guys, content like this is extremely hard to find online. I personally wasn't able to find any myself. I had to go and become a testing guru, and testing is something I avoided in my career for a long time. But now I will not build an application that I'm shipping to a production environment like the App Store or for a client that they're deploying internally without unit tests. For example, I just built an app that cost a company $100,000 to build. I think I have almost 500 unit tests written for that application, and it's over 40,000 lines of code. So you can imagine the confidence that gives me when I go and make a change like that, and I can just run my tests and make sure that everything functions and behaves as expected. And then it's like, hey man, my test passed, thank God, I know I'm good. And I don't have to ship something and then just hope it doesn't break in production after I make a change, right? But anyway, that's my unit testing rant. Like I said, we are not going to be implementing that in this course, but if you guys want to learn more about testing and how that will ultimately make your life so much easier as a developer, and also how it will help you in the professional world, take the test-driven development course. But anyway, guys, let's do a quick recap of what we just did here. So we wanted to avoid potential typos in our product service, right? And that came down to passing in raw strings with our endpoint path. So the first thing we did was build an enum, and we saw that that was better. But we noticed that we could still pass in raw strings and our code would still compile. We had no compile time enforcement of a value type being passed in. It was a string or raw string, right? So then we modified our API request model to introduce, at the time, the product endpoint path. But like I said, that pretty much makes this useless for other components that would need to implement this API request, right? So then we introduced this new model, which is our API route. And this is something that we can add to the more routes we add to our project. So for example, when we add our users feature, we will simply add a users case, a set of user routes, which then ultimately makes our networking layer and our routing significantly more flexible, because now we're not bound to a specific set of routes. We are, using this centralized structure with these associated values to say, hey, when we're looking at the products feature, these are all the paths associated with that. When we implement a users feature, here will be all the paths associated with that. And that's what we pass into our request model. So it's ultimately really, really flexible. Something else you guys might see is a raw case where you can just pass along a string. But I don't like the idea of implementing this because once again, it just introduces, possibility for errors to happen with typos and stuff. Because technically anybody could just always use the raw case and they wouldn't be forced to use these typed cases with these, associated values. So I personally don't like doing that because there's nothing that you can't just add to this enum. It's completely and fully flexible. So guys, that's a huge, massive improvement to our code. Once again, let's go to the chat. Sup chat. And I'm going to say, rate this out of 10. Again, I haven't implemented error handling yet, so don't count that. Let's see what we got up to. Let's see if we made improvements or if that was just one big waste of time. Okay, still a 9 out of 10. So here's what we're doing strong. We definitely have clear abstraction here, and this definitely helped with that, where we sort of extracted our endpoint paths out to an actual structure or typed enum. So guys, that's going to wrap it up for this one. In the next one, we are going to get started with implementing our users feature, and I'm going to give you guys a lot of the starting code for that. So just make sure you download the starter project for the next lecture because it'll contain the user models and the UI and stuff that we don't need to waste time building out. So that's what we're going to be doing in the next one. And then ultimately we're going to see what we need to do to make our networking layer even more generic so that we can have a reusable networking layer across components or features, because right now we don't have that. So thanks for watching this one, guys. We'll see you in the next one. Peace. What's going on, everybody? Welcome back. In this video, we're going to be getting started with implementing this users feature. So I have available for download the starter package that you need for this that includes all of the models, all of the UI, and a basic view model as well. It does not contain the service or networking code just yet. That's what we're going to be doing in this video. And we're really doing this just to get some extra reps in with how to build and architect and implement our services. We're pretty much going to be following the exact same pattern as our product service. So if you guys want, you can take a look through the code real quick. We just have the model, view, and view model folders here. So just to do a super quick run through before we get started, here's our user list view. That's what you see on screen. Displays these users in this user row view. And we also have our user form view that we use to create and update users, very similar to our product structure. Here's our models. We have our user here with some mock users. We have our user form intent, very similar to our product form intent. Our user path right here. So we've already built out our API routes here. We just need to update our global API routing. And then we have our user payloads as well. Create user request, update user request. We have this function to check email availability if we want to implement that. And we also have that in a response payload as well. So then guys, our view model is really, really simple right now. Our load users function is just grabbing our mock user data. So that's it for the users feature. Now we're going to go ahead and get started with implementing our service. So go ahead and create a service folder, and we're going to create a new file. This is going to be a Swift file, and we're going to call it user service. So I'd like for you guys to potentially pause the video and see if you can implement this in pretty much the same exact pattern that we did in the product service. It's going to be the exact same architecture. So maybe pause the video and see if you can implement that yourself, because we're going to be going through it pretty quickly. I'm going to be copy and pasting a good bit of code because we already have a solid foundation in our understanding of how these networking layers are built and the architecture of them. So pause the video, see if you can build it out, and come back to it once you're done. Alrighty guys, so we are going to start this off with creating our protocol. So we're actually only going to be working with these three functions. The check email availability one, I had that running like when you create a user, check if the email is available first, but it seems like the API is busted because it always said that the email wasn't available. So we're not going to be including that one here. We're just going to be doing fetch, create, and update. All right, so let's go ahead and start implementing this. We're going to create a struct user service, and it's going to conform to our user service protocol. And now we're going to implement these functions. Let's just hit apply. So guys, here's our fetch users, create, and update. So going back to our product service briefly, if we go here, we are going to copy this exact same format with reusing our API request model. And we're also going to grab this execution function here to help us with executing our API requests. So let's go ahead and grab this first. It's going to be the exact same between the two services. So I'm just going to paste that in here, and bell should be ringing off in your brain right now if I've taught you guys anything up to this point. And it's that we have the exact same code copy and pasted in two places, which indicates to me that we need a refactor and we need to build out some sort of API client that handles this request execution for us. We're going to get to that in the next video. In this video, we're just going to build out this user service. So we need this base URL. So guys, we are going to go up to the top, or actually we can just go to the product service because it's the exact same thing. And once again, we're copy and pasting code. So that means we should probably refactor this out to like some sort of constants file where we just have this base URL for our API in one place so that we don't need to worry about misspelling it or updating it in multiple places. For example, if it changed to V2, we would have to go do that in our product service as well. So now our execution function is good. Next up, we can go back to this product service, and in this like create product function, we can just copy this code, go back to our create user function, and we just change the type in the generic specifier to be a user because that's going to be the response type. Method is post, and now we need to update our path here. So we notice we don't get any other errors in that function. We're going to leave these be for now. Next up, we're going to go to our API route, and we're going to add a case for our users. And guys, I also renamed this to just product endpoint. I didn't like product endpoint path. It was a little verbose. So next up, we're just going to say user. What is that model? It is our model folder, user path. So let's actually call this user endpoint. And we'll go back to this guy and say user endpoint. And now in our computed property, because we're using a switch statement here, we're going to say case users let endpoint return endpoint.path. And our error should go away here. And then back in our user service, we can go and update this to .users.list. So the list is just like, the list endpoint is just v1/users. That's the creation endpoint. You guys could check out the documentation to verify that. But anyway, guys, let's keep going. Our fetch users function, once again, we could go back to product service, and in fetch, we can copy and paste this code. Go here and just update this to be an array of users. And this is going to be .users.list. And we're done there. And next up, for our update function, we're just going to modify this to a put, and we're going to say users by ID, and we're going to pass in our ID from here. So we can see how quickly we were able to implement this user service based on how we structured our product service, right? We're reusing this API request model. We have this helper here. And everything that took us like what, a minute or two, right? And this is a super clean implementation of this service. The only two problems we really have here are that this execution function is copy and pasted between the two files, and this base URL is also copy and pasted between the two files. But like I said, we're going to be implementing a refactor in the next video where we build out a reusable networking client to handle our request execution so that we don't have this repeated code in multiple surfaces across the application. So now that we have this, guys, we can just go implement this stuff in our view model, and we will then test it out. So in load users, we're just going to have a do catch block, and we are going to say self.users equals try await, and we actually need to add our service in here. So we're going to say private let service, which is our user service protocol. Then we're going to say init service, which is of that type user service protocol, self.service equals service. Perfect. And then we're going to say service.fetch users. And then here we'll just add a print statement, failed to fetch users with error. And we'll just add our error in there. And we're going to do the same for our user creation. So do catch block, we're going to say let new user equal our try await service.create user with that payload. And that just uses our create user request. And then we're going to say users.insert new user at element 0. And then for our update functionality, it's going to be pretty similar to this. Actually, the autocomplete got that wrong. We're going to go here, let new user equal try await service.update user ID with that payload. And now we need to find that user in our array, and we'll do that using an index lookup. So we'll say guard let index equal users.first index where 0.id is equal to our ID that we pass into this function, else return. And here we will say users index equals our new user. Right? Pretty standard stuff here at this point. And once again, it just goes to show you how easy this stuff is to implement once you get the architecture down pat. So now that we have this, guys, you could hop over to the view, and in our users list view, we already have this task right here. We actually need to pass in our service now, and we can just say user service. And now that's good to go. This should actually load our users from the API now. And then we can handle all the stuff in our user form view as well. And that will wrap up this user feature. And guys, we can now see our users loading from our API. So this is looking good. And next up, we can hop into our user form view and take a look at our submit function and see if that's working as well. So we're already doing the switch on our intent, and we create our payload here. We call our view model function. And once we do that, we could actually just go ahead and dismiss this screen, and we could just run that dismissal outside of this switch statement so we don't have to repeat that call. And this is looking good, man. So we'll go ahead and test out our creation. Once again, I'm not sure if the update's going to work. We might get an internal server error, but if we go back to our user list view and let's see if our data loads. Actually, it doesn't really matter. Yep, there it is. And we'll just go here. I'll see if I can create app stuff. We'll say appstuff@gmail.com. Password is whatever. And we'll hit create. And it looks like that succeeded because it successfully dismissed. And if we check this out, I am right up here at the top of the page. So our creation function is working. Let's see if we can call this update function on myself here. Maybe it doesn't work for like their sort of admin users that they have created on the API. So guys, if you just swipe on this, I have this edit button here. It launches the form. We could now try to modify our email. We could say appstuff like .test or something, save. And okay, the update function does work. So maybe you just can't do it to like the existing users they already have on the API. Those are probably locked or something. So we have our user service completely implemented now. This is looking awesome. And you guys just once again should notice how similar it was to our product service. This is the architecture pattern that I like to follow when I'm building out these features. It's very simple, straightforward, MVVM. You use protocol-oriented services. We have our request model that helps us build these requests and our execution helper. So this is like level 1 of a networking layer to me. There's a lot more stuff that we're going to be implementing starting in the next video with our reusable generic networking client that is going to allow us to extract this execution code to a helper. So much like our API request model, we'll be able to use that across multiple services in the application. So thanks for watching this one, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome back. In this video, we're going to build out a generic and reusable API client that is going to be responsible for executing our network requests. So if you guys remember, we have this execution function duplicated between our user service and our product service. So I did that on purpose to illustrate the need for the refactor here, instead of just jumping straight into creating this networking client. So we're going to go over how to refactor this code into a generic and reusable networking client now. So in our networking folder, we're going to go here and create a client called, or a folder called client. And we're going to create a Swift file. And we're just going to call it API client. And we are just going to go and grab this execution function here. So we can just copy that for now so we don't cause any errors just yet. Go back to this API client. So we're going to create a struct called API client. And we're just going to add this execution function. And we're just going to see what goes wrong, right? So it's going to throw some errors, and that'll help us figure out what we need to add as input parameters to this guy. So right now, it just needs a base URL, which is a URL. We're also going to add a session, guys. So it's going to be URL session, and the default value is going to be shared. And then we're going to add a decoder as well, which is a JSON decoder, and it's going to equal the default JSON decoder. And that's it for now. So one thing I want to touch on before we go forward is why I added this session and this decoder as input parameters to this API client. So the reason for that is we want to be able to potentially configure a URL session or JSON decoder and then pass it into this client so that it has those configurations attached to it. For example, if one of our services that implements this client had different decoding rules for dates or decoding strategies, we could then configure that decoder and pass it in here. That way we are not bound to using this default JSON decoder. And the same goes for our URL session. So we just need to make some quick modifications here. Here, instead of saying URL session.shared, we are going to use our class level property for the session. And here we are going to use our decoder instead of the default one. So this way, whatever we pass into this client, whatever configurations this session has or configurations this decoder has, it will take effect in this execution function. So we're good to go now. The only remaining step here is to implement this in our two services, our product service and our user service. So let's go to our product service first. We can delete this function. We don't need it anymore because that's now been extracted. But we do, however, need to create our client now. So guys, what we're going to do is say private let client, and this is going to be our API client. And when we initialize this thing, we are going to initialize it. And I don't think we actually need to pass in a client here. We could just configure our client right here. Client equals API client and pass in our base URL. We don't need to pass in a session or a decoder. We can just use the default values attached to it there. So now we just need to say client.execute, 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 client.execute. And that's it for our refactor. So now we will be able to reuse this exact same client inside of our user service, right? So if we go and hop into our users folder, user service file, we can literally just go here and copy and paste this code. And now we have access to our client. We can delete this function here. And then we just need to say, once again, client.execute, and we can copy and paste that in our other functions. So that's a beautiful refactor right there. Now we have a networking client that can be reused across multiple services, and all of our code regarding our network execution is centralized to the client. Notice how that execution function just takes in any generic API request and then executes it. So here we configure our request model based on the needs of this function, and then we just use our client to execute that request. And both our API request model and our API client are flexible with their use of generics here. So we can return any sort of response type. We just need to configure the request to tell it what type of method it has and where it needs to go to do what it needs to do, whether that's getting data from a certain endpoint, posting data to a certain endpoint, whatever it may be. So this is now super flexible, super reusable, and it's way easier to scale, maintain, and debug. And this is just the beginning of what we're going to be doing with this API client. We have yet to implement things like cache policies, network logging, retry policies, network interceptors, and all of that stuff. And now that we have all of our client code centralized in this single component, we only have to write that code in one place, as opposed to having to distribute it across multiple services with copy and pasted code, which just isn't a scalable approach. So next up, guys, let's just go and do some quick tests to make sure that this still works. So in our user list view, we just want to make sure our users still load here. And if we know that they're loading, we'll know that all of the other requests work as well. And then we're just going to check the same thing for our products, and we should be good to go with this refactor here. So we can see our users showing up there nicely, guys. If it's not showing up for you, you could just remove this has loaded check. That just prevents the task from running multiple times. So if you guys just remove this, it will load every time this screen appears. I sort of did that just sort of as a basic form of rate limiting. We don't need to constantly execute that function every time this view appears or every time we make changes to our code. But we noticed that it was working, so let's just go ahead and check our product view as well. So in products, we'll go to products view. And this should just load our products using our new networking client. And we should be able to see our products loading there. Guys, if you're not, just go ahead and check your console with the Canvas console selected. It looks like at one point we did get a timeout error. That could be for all kinds of different reasons. So you can just modify some code in here to get your preview to rerun, but eventually you should see these flowing up. Our code is working. So the next thing I want us to do before we end this video is resolve one final issue where we have this base URL repeated between both services. We should extract this to a constants file. So let's go ahead and do that now. So let's just go ahead and copy this code or cut it out. And we're going to go to our API route folder. And I'm just going to create a struct here called URL constants or something. And we could just go ahead and paste this in as a static property. So static let base URL. And we could actually call this our fake store API URL or fake store URL, something like that. And now, guys, when we go back to our product service, we could just go here and say URL constants dot fake store URL. And we can do the same thing in our user service as well. So let's go to our users folder, user service, and delete that. And we're going to say URL constants dot fake store URL. Just better to have that centralized into like a structure so we don't have to type it out in multiple places and worry about malformed URLs or modifying it in multiple places. So that's a pretty smooth refactor, man. This is looking really, really good. And in the next section, we're going to continue on with implementing an error handling API for our networking layer. So get excited for that, guys. We'll see you there. Peace. What's going on, guys? Welcome back. In this section, we're going to be introducing a error handling API into our networking layer. So right now, let's take a look at what we're doing when it comes to error handling. So we have some basic error handling implemented here. Like, for example, if we get an invalid response here, we throw an error. We also throw an error down here if we get a response that is not in the 200s. So this definitely isn't bad. But if we go into our view models and stuff, like if I go to core, products, view model, we just have a bunch of print statements here for our error handling. And this is not good. We need to display error messages to users, letting them know what went wrong and what actions they could potentially take in order to resolve the issue. For example, could they try again in a little bit? Could they hit a retry button? Are they not connected to the internet and need to check their internet connection, stuff like that, right? So in our error handling API, we're going to introduce both user messages and debug messages to help us as developers figure out what's going wrong and have user safe messages or user friendly, more readable messages to help the user understand what's going wrong. So in our networking folder, we're going to create a new folder and it's going to be called error. And in this one, we're going to create a new file. And this is simply going to be called network error. You could call it API error, network error, doesn't really matter. So this is just going to be an enumeration, guys. So we're going to create an enum called network error, and we are going to introduce a couple different cases here. So the first one is going to be a transport error, and this is going to have a URL error as an associated value. We're going to have an error for invalid responses. We're going to have an error for HTTP status with a code attached to that as an associated value. We're going to have a case for decode failed. So we're going to say decoding failed, and we'll pass in an error to that as well. In case unknown, and we'll pass in an error to that as well as an associated value. So let's talk about what each one of these cases represent. So what is a transport error? So that's when something goes wrong during transport of your actual request. Like you tried to send the request and something failed during that sending process. Some common examples of this include when people aren't connected to the internet or if their request timed out, just basically anything that goes wrong during the transport of your request. Invalid responses, if we get back something invalid from the server, we'll handle it here. Bad status codes like 400 or 500 status codes, we'll handle that here. And we attach the code as an associated value so that we can give different messages based on different error codes. For example, 401 is different from 403, from 404, from 500s, etc. This we'll use when our decodes fail. And this is for any other unknown error case, and we'll just attach the error there as an associated value. So next up, guys, let's go ahead and create a user message, which is a string, and we'll do a switch on self. So here is our transport case. So let's go ahead and just make this URL error. They cased that weird. And we're going to do a switch on our URL error.code here. So we'll say URL error.code. And we could say case.not connected to internet. And here we will just return no internet connection. Check your network connection and try again. So guys, if you don't feel like typing all this stuff out, this will be available in the completed source code. However, I think it's a good idea just so you have a detailed understanding of what each case represents and what we're really doing with this error handling API. So another one we'll look at is a timeout error. So we'll say case.timedout and we'll say the request timed out, please try again. And by default, we'll just say return a network error occurred. Please try again. So we'll have more specific messages for these cases, but by default, we'll just say, hey, something went wrong with our network. Please try again. So invalid response, this one is pretty straightforward. We're just going to say the server returned an invalid response. Now, things get a little bit more interesting here with our HTTP status. So we're going to do a switch on the code, and we'll say case, let's start with 401. So when we get a 401 error, what exactly does that mean? That's an authorization error. So this is going to come into play when we do things like JWT authentication to let the user know, hey, you're not authorized. Please sign in again or try again, right? So these are where these user-friendly or user-readable messages really come in handy. You don't want to show the user like debug error messages or error messages in their raw format because one, they're ugly. Users won't understand that unless they have a programming background, and it doesn't really help them with what to do next, right? So next up, we have a 403 error. What does that mean? It means you don't have permission. So it says you don't have permission to perform this action. This is like a scope issue. Then we'll have a 404 error as well. And then, guys, this 404 is obviously when the requested resource could not be found. You see this all the time when going to web pages that don't exist, right? And then we have some other ones. We have 409. Now, this is going to be a conflicting error. The action conflicts with existing data. And then another big one here is a 429 error. This is going to come into play when we introduce rate limiting into our API. So this is going to be too many requests. Please wait a moment and try again. So that just lets the user know, hey, you're getting throttled or rate limited. You need to wait a little bit before you try to refresh the data, right? And then, guys, by default, we need to do our 500 errors. So anything in the 500s mean that's an internal server error. The server's having trouble right now. Please try again later. That's going to be something the user just can't do anything about. But this is pretty much all we need to do for our status code handling. But by default, we need to just say, hey, something went wrong. Please try again if it's anything other than these codes. All right, so next up, we have our decode fail. We don't need the error attached here because the user doesn't care why the decode failed. That's going to come into play with our debug messaging or our network logging error. So when the decode fails, we'll just say we received data in an unexpected format. And unknown, we're just going to say something went wrong. Please try again. You could potentially add the error localized description, but I don't think the user really needs to see that. So that's going to be it for our user-friendly messages. So next up, guys, we're going to have debug messages. So this is going to be developer-facing error messages. So we're going to say var debug message, which is a string, and we're going to do a switch on self. So for transport, here's what we're going to say. We're going to look at the URL error. We're just going to say return transport error. We're going to get the error code and the error localized description to tell us exactly what went wrong. Let's see. We could just call this needs to be URL error. And invalid response. This doesn't need to be anything fancy. Just said invalid non-HTTP response. here we can say, guess what? This is just the code, right? Because as developers, we should know what these codes are, right? So we can just look at the code and say, hey, we got a 401, a 429, whatever. Decoding failed. Let's go ahead and just paste this in here. I actually don't like the localized description on decode errors, guys, because the actual error just gives you back what exactly went wrong with the decode. The localized description is kind of just says, hey, the decode failed. It doesn't tell you what in the decoding process failed. And for unknown, we could look at the error localized description there. So this is simpler for debugging because as developers, we should just be able to look at this stuff and say, oh, hey, a transport error happened or an invalid response came back. We don't really need to get too much more detailed here, in my opinion, but you guys can get as detailed as you want. We could also access the user message if we want. So we don't really need to duplicate a lot of that logic there. Okay, so next up, guys, we are going to get an error description here, and we're going to conform to localized error up at the top. So this needs to conform to both error and localized error so that we can take a look at that error description, and we will just take a look at the user message that comes back because that's a little bit more descriptive. And last thing I want us to do is get easier access to our status code. So we could add another computed property here called status code. And we're going to say guard case.http status let code equals self, else return nil, and then return the status code. So this just gives us easier access to that status code if we want to look at that. So that's really it for our network error, guys. The next thing we're going to do is create an error mapper so that we can easily parse whatever error comes back from an API call into our network error enum. So it's going to just serve as a mapping from a standard error type into our network error where we can get more descriptive messages to see what went wrong. So we can create another enum called network error mapper. You guys could make this a struct as well, kind of the same thing. They're both just value types that we're just going to place some static functions on. So we're going to have a static func to map some error type into our network error. So first off, we're going to say if let network error equals error as the network error. So if we can cast that as our network error to begin with, we're just going to say return that network error, right? So next up, if we get a URL error like this as URL error, we know that something went wrong with transport. And then we're going to pass in that URL error. And next up, guys, we can literally just say return.unknown and pass along our error, right? So now this mapper will always normalize our error into this network error type to give us back those debug and user messages that make our life easier to display error messages to users and to ourselves as developers. So next up, we're going to have a func for HTTP status with a code, and this is going to return a network error. And it's just going to be return.http status with that code. And next up, we'll have one for our decode fail. So static func decode failure with an error, which is of type error, and it will return a network error. And we're just going to say dot decoding failed and pass that error along. And here we actually don't need to stay return. All right, so now we have our network mapper and our network error. Once again, the mapper just helps us normalize our errors into this desired network error type that we can work with to display user-friendly error messages and debug messages. And this is going to come in handy even more when we introduce our network logging feature. So when we want to log errors in our network log. So the next step, guys, is going to be to implement this error handling inside of our API client and other places in the code like our service layers and stuff like that, to ultimately then be able to display alerts to users or error messages to users and stuff like that. So let's get started with that next. So we are going to hop into our API client and get started here. So first things first, guys, let's hop into this HTTP response validation where we try to cast this as an HTTP URL response. If it goes wrong, we are currently throwing in a URL error. And with our network error mapper, this might map to the correct error, but what I want us to do is just avoid having that like transformation need to happen. And we can just go here and throw network error dot invalid response. And here we can just go and delete all of this code here. And then we're just going to throw our network error dot HTTP status, and we're going to pass in this status code here. So next up, we're going to try to decode this data. We could potentially wrap this in a do catch and then throw a decode error. But what we're going to do instead is just wrap this entire thing inside of a do block. So we're going to cut all our code, place that in a do block, and then we'll catch our error here. So for example, if something goes wrong in this try await session.data, we'll catch the error here, and we will map it accordingly. So we're going to say let mapped equal network error mapper, and this is where this comes into play, dot map our error. And then we're just going to throw that mapped error. So let's break down how this works really quickly. So in this catch block, this is where we start to utilize this network error mapper. So let's go back into this map function to see exactly how it works. So we already know that if we throw an error and it can successfully cast as this network error, we just return that, right? But if we were to get some sort of URL error, like in the session.data for that request, then we map this into a transport error, and all other errors will just get mapped to this unknown case. And then we just pass the error along as this associated value, so we can handle it accordingly there. So back here, once again, in this catch block, we map our error and throw that mapped error. So how is this going to work inside of our implementations, like our product service and our user service? So let's go to our product service really quickly. So here, when we return try await client.execute, if anything goes wrong in this execution process with that try, it will then throw our mapped network error, and we can handle that accordingly in our view model and ultimately propagate that back over to our view to display an alert message or some kind of error message on screen, right? And it's the same in each one of these requests, right? So our error handling is now centralized into our networking layer. So this is working beautifully here. So in the next video, guys, we're going to introduce our error handling UI implementation. So inside the product's view model, where we catch these thrown errors, we will then have some sort of error message property or error state that we will then propagate back to our view to ultimately display that to our user. And we're also going to be introducing things like loading state that are going to help us with things like empty states, error states, loading states, completed states, so on and so forth. And we'll tie our error handling into that state management. So that's going to do it for this one, guys. We'll see you in the next one. Peace out. What's going on, guys? Welcome back. In this video, we're going to introduce the concept of loading states into our application. So for example, right now, as our products are loading, we just see a blank screen. So we want to indicate to the user somehow that we are trying to currently load data. So that by displaying some sort of progress indicator, so that they know a process is ongoing and they just need to hang tight while we try to get their data loaded onto the screen. And we are also going to be tying different states into that loading state with things like empty states and error states and completed states. So this is a very common pattern that I use when it comes to networking and it comes to state management related to that networking, right? So what we're going to do is in our core folder, we are going to create a models folder, and we're going to go here and create a new file, and we're going to hit next, and we're going to call this loading state. So this is going to be an enum, and it's going to be called loading state, and we're going to have case for idle, case for loading, case for loaded, case for empty, and a case for error. So let's actually move this around a little bit. I like to add loaded last, just because when you go through that switch statement, it makes it easier so that loaded isn't mixed up there in the middle. And this looks good, right? So we're also going to add some generics to this, guys. So we're going to go here and add a value specified as a generic type that conforms to the decodable protocol. And that way, when we are in our completed or loaded state, we are going to pass along that value. So we're just going to go here and say value. And also for our error, we're going to attach a string to it, which is going to be our error message. So this way we can reuse this across multiple features in the application. We'll be able to reuse this loading state for our products and for our users because both of those types conform to this decodable protocol. And when we're in our loaded state, we can then display whatever data we get back from our networking request that corresponds to this completed or loaded state. So let's go ahead and start implementing this now. So inside of our products view model, we are going to add a variable to track this state. So we're going to say loading state, and we know that we need or going to be looking at an array of products here as our generic type, and we are going to default it to idle. And we actually need to specify this as loading state, I believe. And then we're going to delete this products property. That's now going to be attached to our loading state. So here, guys, we're going to say let products equal try-await service.fetch products. And whenever we complete this fetch, our loading state can have one of two potential states. If it succeeds, it's either going to be empty or it's going to be loaded, right? So we're going to say loading state equals products.isEmpty, yes.empty, oops, no.loaded, and we're going to pass along our products just like that. And guys, we actually need to move this colon here. So this needs to be look like this. That was my bad. Just typed that out wrong. So the loading state is casted at this loading state type. We specify our model for our generic and we start it off as idle. So when we start loading our products, we are then going to set our loading state to .loading. So we can see here that we can transition between states very easily with this enum architecture. And in a little bit, we're going to switch through this loading state in our view to display the corresponding view for each particular state. So for example, the loading state will just show a progress view. The completed state will show our list. The empty state will show an empty view, so on and so forth. So this is where this ties into our error handling. If something goes wrong, we're now going to say loading state equals .error, and we're going to say error.localized description. We just pass that string along from our localized description that we get from the error to this error case. That way we can display it either in an alert message or on screen to the user and potentially prompt for them to retry or something like that, right? So next up, we no longer have this products variable, right? Everything is now tied to this loading state. So we're going to need to modify this create product, update product, and delete product functions to work accordingly with our loading state. So we're actually going to create some helper functions to help us do this. So let's just go ahead and delete these lines of code that are throwing compiler errors. And we are going to go down here, and we also need to delete this guy too. Let's actually cut that because I think we're going to need it. So hit Command X on that. And we shouldn't get any more errors in this file. So we're going to create three helper functions here. We're going to create a private function called insert or start products with a product, which is of type product. So the name of this function will become clear in a second, or why we named it this. So we're going to do a switch on our loading state, and we're going to start off with our loaded state, and we're going to get our products back from our associated value, but as a variable here because it needs to be mutable now. So what we're going to do is say products.insert this new product that comes from our input at the 0 index. And then we're going to say loading state is equal to .loaded with our products that we modified, right? So that's how we look at the associated value. We mutate it, and then we reset our state or reconfigure it with that new data type, or sorry, that new updated data. And then for everything else, guys, so this is our empty state, idle state, error state, and loading state. We're just going to say loading state is equal to .loaded, and we're going to pass in our product as an array. So why are we doing it this way? So this helps us between state transitions. So let's imagine we were in an empty state, and then we create a new product and we insert it to our list, right? So if we were in that empty state, which happens in this default case, then we're going to say, hey, we were in our empty state, because let's imagine that our load products function came back with an empty response. So our loading state is currently loading. So then we go and create a new product. It's going to say, okay, we created a new product. Let's insert or start the products list, basically. So if it was in that empty state, then it transitions back into our loading state. So what we're going to do now is in our create product function, we can remove this print statement now. We can just say insert or start products with that new products, right? And that works for all other states as well, guys. If it was in an error state and then we go and create a new product, we want to go from error state to .loaded with that new product in that array. So it will display that in our list and it won't just stay in our error state. So then we're going to make two more functions. One is going to be private func replace product if loaded. And this is going to be with that product. And we could make sure our naming is consistent here and say with. And what we're going to do is we're going to make sure that we're currently in the loaded state. So here's how we're going to do that. We can say guard case.loaded var items is equal to our loading state, right? And then we are going to find the index of that product like this. And then we're going to say items, or do we call it items? Let's call it products to make this clearer. We're going to say products index equals that new product, right? And then we're going to say loading state equals .loaded with our new products. And then we're going to go here and call this function in our update product guy. So we're just going to go here and say replace product if loaded with our new product. And then we need to do the same thing for product deletion. So we're going to make a private helper called remove product if it's been loaded. And we're just going to pass an ID in here. And we're going to make sure we're in this loaded state once again, because if we're not in that loaded state, guys, we can't update anything, right? Oh, I need to update this to products, and this needs to be loaded. Perfect. Okay, so next up, we need to grab our index once again, and then we just need to remove that product. So we're going to say products dot remove at index, and then loading state is equal to .loaded with that updated data set. And then here, when we delete a product, we're going to say remove product if loaded with that ID. Okay, this is not product.id, it's just ID that comes in from our input parameter for this function. And now we're good. So guys, if we try to build this, it's going to throw an error because now we are encapsulating everything around this loading state. So guys, really quickly go up here and add main actor as well. I forgot to do that. So now we need to go to our view and do a switch on this loading state and render a view for each different state. So in our products view, let's go ahead and grab this entire scroll view and just cut it. And we're going to create a group. We're going to do a switch on our view model dot loading state. And idle and loading can typically be the same. So here we're just going to show a progress view. And in the empty state, guys, we can just simply say text no products to display. I would typically use a content unavailable view here, but this is fine for now. And our error state, guys, is just going to be, we can call this let error message. Just pass along our error message. And then for our loaded state, we're just going to paste in that scroll view there. So let's see, why is this yelling at me? Okay, it's because we're still using viewModel.products. So here we're going to say let products, and we're just going to go here and delete viewModel.products and replace it with products that comes back from our associated value for that loaded state. So now let's go ahead and refresh our preview, guys, and see if that works. And then we could even simulate some errors. We could like throw a malformed URL in there or something to see if it goes into our error state. So we can already see here that we get this beautiful progress indicator showing up, indicating that our products are loading. So for some reason, I'm not sure why, I'm getting a lot of timeout errors here. So we should eventually get some sort of error message on screen or our products once they load. So we'll see what happens there. We do get a timeout error, and this is bad and good in a way, right? Like we shouldn't be getting timeout errors, but we know that our error state is now loading correctly and displaying on screen. So when we tried to make that URL request, it timed out and then displayed a user-friendly error message to our user. And ideally, we'd add some sort of retry button down here, but we are going to get to that when we implement our retry logic. What I want us to do really quickly is just run this to the simulator and see if this error is persisting. I think this might just be a preview problem. So I'm just going to run that to the simulator real quick, and we'll see if our products load. And then the next thing we need to do is implement that inside of our users view model and update our UI there as well. Okay, so yeah, our products just load instantly, but it's kind of cool that we got to test out our error state without having to go through manually simulating errors in our API or networking. So this is looking good, guys. Let's go ahead and jump into integrating this into our users view model next. So we're going to go to our users folder, user list view model. We're going to remove this property here. We're going to say var loading state. Loading state, and this time it's going to be an array of users that we get back equals dot idle. When we start loading our users, we're going to say loading state equals dot loading. We're going to go here and say let users equal that, and we're going to say loading state equals dot users dot is empty, yes dot empty, no dot loaded with our users, right? Okay. So next up, we need to introduce those helpers here as well. And we could maybe wrap that up into some sort of extension or something. But for now, to make like the reusable sort of helpers that can modify any array. But for now, guys, we're just going to do this with the same way we did it in our product service, or product view model rather. So here, copy and paste this code. And this is going to be insert or start users with user, which is of type user. And then we're just going to rename this to users.insert user at 0, loaded with our users and our individual user there. And here we're going to say replace user if loaded. And we'll just go through and update this code. And like I said, we will do a refactor here so that we don't have copy and pasted code between our two view models, because this is all pretty much the exact same thing. The only thing that differs is our data type, right? So let's see. Now we need to just say it equals that user. This is going to be called users. And users right there. And this is users, 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 users. And users right there. And we can now delete this. And let's see, we can delete this as well. And we're going to say replace user if loaded here with that new user. We actually don't need this deletion function because I don't think they have an API for deleting users. And here we're going to say insert or start users with our new user. Hit Command B. We don't get any more errors here. Oh, yes, we do. This is just going to be with user.id. Okay, once again, hit Command B. We should just get some errors in our view now. And we're just going to go through the same thing. So let's go ahead and grab this code, cut it, create a group. We'll switch on our view model dot loading state, and idle and loading will be the same thing. And we will just add a progress view, empty, text, no users yet. And here we'll call this error message. And we'll say text error message. And here we'll call this users, paste our code in. And we just need to say that this is no longer grabbing that as the viewModel.users, but now grabbing it from this associated value. All right, that should be good to go. Let's go ahead and run this code to the simulator because for some reason the preview is being buggy. And we should be able to go over to our user screen. We see that loading state show up there beautifully. Ooh, maybe we're getting a timeout error here too. Maybe I'm getting like rate limited or something. I'm not sure. Okay, our users load. That looks great. Here we see that we transition into our loaded state and we're looking good, guys. So really quickly, let's test out creating a user just to make sure that still works. Or you know what? Let's actually do this. Let's go back to our user's view model and simulate an empty state. So here, let's just pass in a blank array, right? So this will illustrate the concept of this insert or start functionality. So we're going to manually simulate an empty state here. And, oh, actually, yeah, so we can't do that. We're just going to go and we can just add a comment here to comment that out. And we're going to say no matter what, it's just equal to empty. And here we can just pass our users back in. All right, so now, okay, I spelled that wrong, but we're going to test out creating a new user. And we should see that we transition out of this empty state into our loaded state with that newly created user. So let's just call this app stuff tester 123@gmail.com and some random password, create, and check that out. We transitioned out of that empty state into our loaded state with that newly created user, right? So that's looking really good, guys. And we know that our error state is working as well. So let's just go ahead and delete this code here to bring back our standard functionality. So that's going to wrap it up for this video, guys. We introduced this loading state that helps us manage all of the different potential states we can be in when fetching data from a network and when that process completes with empty states, error states, and loaded states. And we are also successfully moving in and out of states accordingly with different or varying conditions, right? Like empty state to completed state or error state to completed state, etc. So this is looking really good. So like I said, that's going to wrap it up for this one. We'll see you guys in the next one. Peace out. What's going on, guys? Welcome back. In this video, we're going to be implementing a refactor to deal with the duplicated code we have involved in mutating our loading state between our products view model and our user list view model as well. So the approach we're going to take here is implementing a protocol that both of these view models will conform to, and we will add these methods to a protocol extension so that they are centralized to a single component. And we can then reuse those protocol extension functions here or in both view models rather, so that we don't have all of this duplicated code. It's just going to make things a lot cleaner and a lot more scalable. So let's go ahead and get started. So what we're going to do, guys, is in this models folder, we can just create this here for now. We're going to create a new file and we're going to call this list mutating. So this is going to be a protocol. So here's what it's going to look like. We're going to have a protocol and it's going to be called list mutating and it's going to conform to any object. And we're going to have an associated type here for our item, which is identifiable and decodable. So this is going to represent either our user or our product, right? Those are both identifiable and decodable. And next up, we're going to have our loading state here. And this is going to be our loading state. And the generic is going to be our item associated type. And we are going to go here and say that we are going to be able to get this and set this. And next, guys, we're going to create an extension on this list mutating protocol. And we are then going to implement those helper functions here. And let's go ahead and go back to our products view model. We can grab all three of these functions and we can just copy that and go back to our list mutating and paste these in here. These are no longer going to be private functions. And we are going to replace remove product with remove item, replace product with replace item, and insert or start. And we can just say with our item. And this is going to be of our item associated type here. And this needs to be an item, and the ID there is fine. And here we can call this items. Here, this will be items. Let's just go ahead and fix all these errors here. Items, items, items. And this will be our item that we pass in. Items here. And this will be our item.id, and we can access that because it conforms to the identifiable protocol, so we're good there. And here we'll call this items as well. And let's see, we got to replace that there as well. This needs to be item. This needs to be items. This needs to be items. And this needs to be items as well. And then this guy needs to be our item that we pass in. Okay, and let's see. I think we need to capitalize this. Yep. Static member ID cannot be used on self.item. Let's see how we can fix this. So where are zero? We should, because this is looking at our items, right? Items.firstIndex where 0.id is equal to our ID. That should work. Let's see what the fix is. Oh, as integer. Okay. Yeah, okay. We just had to cast it. Okay. So we would potentially want to optionally cast that, but this should be fine for now. All of the IDs coming back from our database are cast as integers. Or as they are integer types rather. All right, guys. So we're going to do a more detailed breakdown of this, but this is essentially the foundation of what we need for this refactor. So if we go back to our products view model, we'll be able to go here and conform to this list mutating protocol. And we actually need to add main actor conformance here. And we can remove our main actor conformance from the class itself. And that error goes away. That's a Swift 6 error. But notice how if we build our project, that we're still good to go. Our build should succeed, right? And this is because it's recognizing our product as this associated type, and that conforms to both our identifiable and decodable protocol. Codable obviously conforms to both encodable and decodable. So next up, we can go ahead and remove all of these guys now. So we can just delete that stuff. And we can replace them with our protocol functions that we have implemented on that extension. So we can just say insert or start with our new product. And here we can say replace item if loaded with our new product. And here we can say remove item if loaded with that ID. And check that out, man. That just works beautifully, right? So we can now go do the same thing inside of our users view model. So let's see, go to users, go to view model, delete main actor conformance here, and we will add conformance to our protocol. at main actor list mutating. There we go. Everything there is good. We go here, remove these two functions. We don't need the delete helper, but you guys will be able to now see that we can just say replace with that new user and insert or start with our new user. And that is a successful refactor, guys. So really quickly, let's just go ahead and break down how that works, because that may be a little bit confusing if you don't have a solid understanding of how protocols and protocol extensions work, and also associated types. So let's go back to our protocol here. So basically, the goal of creating this protocol was to extract these helper functions into this protocol extension so that we could reuse them in any type or class that conforms to this protocol, which in this case is our users list view model and our products view model, right? So we need some sort of associated type here. And this is going to represent the thing that we are loading from our API. Whether it's users or products, the thing that those both share in common is they both conform to the identifiable and decodable protocols. So we ultimately need to mutate or modify our loading state, right? So we are using the generics within our loading state, and we can pass that along using our associated type, which is this item here. And when we conform to the protocols in our view models, we just have to specify what this is. And in each case, the users list view model, it'll be our user data type. The products view model will be our product type, right? So then we can now implement this loading state with this associated type. And in these functions, we can then mutate that loading state, because we are using a getter and a setter. So here we insert or start, and we just look at the loading state, and we look at the items, and it's whatever item we specify at protocol conformance. And for example, in the users list view model, our associated type is recognized as this user, which is why we don't get any compiler errors when conforming to this protocol, because it says, hey, you've specified that associated type. And then we simply follow all of the procedures we were doing between those two view models. We now just have them centralized into this protocol extension. So there's a couple different ways you could do this. This is simply how I chose to do it. I think it's the cleanest implementation. You could have global functions. That's definitely an option. I don't think it's the best option, because encapsulated within any sort of structure, which I am personally not a fan of. Another approach would have been to create something like a list manager structure that pretty much does the same thing we did here. Implement that structure inside of your view model and have your helper functions exist on a structure. I personally just like the protocol approach best, because I think this works really cleanly. So that's really going to do it for this video, guys. Definitely want to just mix in some advanced Swift fundamentals there. Anytime I have copy and pasted code between components, as I'm sure you guys may know, I almost always try to refactor that code into a centralized component that can be reused across multiple surfaces in the application for multiple reasons, right? As I'm sure I've explained before, it's more scalable, it's easier to debug, and it's easier to modify. So if we made any updates to this like loading state functionality, we could just go, and like the mutation helpers, we just go here and modify them. Whereas before, if we wanted to update them, we would have to do it in both of our view models. And if we had 5, 6, 7, 8, 9, 10 features that had this mutable list functionality or this mutable loading state, that obviously doesn't behave well at scale, right? So that's going to do it for this video, guys. Thanks for watching. Really hope you're enjoying the course so far. We'll see you in the next one. Peace out. Welcome back. In our last video, we implemented this list mutating protocol to help us modify our loading state. And we conform to that in both our user list view model and products view model to implement a really nice refactor to mutate our loading state. So following up into this video, we are going to be introducing the concept of mutation state. So this is another very important concept when it comes to integrating your networking layer into your UI. And here's what I'm talking about. So when we go and try to execute some mutation operation, whether that is creating, updating, or deleting, it ultimately mutates our data source, right? we don't really have any state management attached to that right now. I wouldn't want to reuse my loading state to handle like an ongoing creation state or update state or deletion state. So in this video, we are going to continue on as an extension of our loading state and introduce this concept of mutation state. And we're going to be doing the same thing when we get to pagination with introducing pagination states like idle, loading more, or we've reached the end of our list, right? So this concept of state management is extremely important when you are trying to build production software. So if anything goes wrong in these mutation operations, that's something that we as developers need to know and our users need to know as well, so that they can perform subsequent actions like maybe retrying, coming back at a later time, whatever it may be, right? So we're going to go back to this loading state model file, or this model folder rather, and we're going to introduce another file, and this is going to be called mutation state. And we're going to create two enums here. One is going to be for our mutation state, and we are going to create another one for a mutation operation. And for this operation, we can either create, update, or delete. So let's go ahead and add those cases, as we can see there. And our mutation state, guys, is going to have an idle state, an in progress state, or a loading state. And we're going to attach a mutation operation to that. And then we're going to also have a succeeded case. And we're going to attach a mutation operation to that. And we're going to have a case for failed with a mutation operation and a string for our error message. So this is our mutation state enum. We're going to now implement this inside of each one of our view models and then hook it into our UI so that we can manage mutation state accordingly. So let's go back to our user list view model, guys. Or you know what, we can start with our products view model. That's what we did first, so let's show products view model some love. So we're going to introduce a property here for our mutation state, and it's going to be of type mutation state, and it's going to default to the idle state. Okay, so let's see how we can now implement this. So let's start with our create product function. So in create product, we're going to go and say mutation state equals dot in progress, and it's a create operation, right? So we get very detailed with our state management here using these two enum types. We're in progress, and we now know what operation is in progress, right? So next up in this do block, if we succeed here, we are then going to say mutation state equals dot succeeded for our create operation. And in our failure block, we're going to say mutation state equals dot failed for that create operation. And we're going to pass along our error.localized description. So as you guys can see here, we'll know exactly what failed. It's our creation operation, and we'll know why it failed with these associated values passed into this enumeration case. So we can do the same thing for our update. We can just say mutation state, equals dot in progress for dot update. And here it will be mutation state. I keep hitting caps lock. That's my bad. Can't type right now. Equals dot succeeded for our update operation. And here it's going to be failed for update with our error.localized description. And we're going to do the same thing for delete, right? Pretty straightforward once you get the hang of it. This is a delete operation. Here we're going to say it succeeded for dot delete. And here we're going to say it failed for dot delete. And you guys are starting to see that we can pretty much just get rid of all these print statements now because our error handling is becoming so detailed. And we will always get back error messages in some way that we could then display in a network log, which we're going to be doing in the next section. And then we can display the user-friendly error messages to the users if needed, right? So the next step, guys, is going to be implementing this inside of our UI. So if we go to our view, we're going to want to go to the product form view here. And this is where we're going to implement our mutation states. So basically when I click that create button, that's when I'm going to want to transition this button here that just has a submit title right now to maybe display a progress indicator. And if my mutation operation fails, then I'm going to display an alert message to the user, right? So let's go ahead and get started with that. So the first thing we're going to do is hop up to the top here, and we're going to add two state properties. One for a mutation alert presentation, which is a Boolean, and another for our mutation error message. So now, guys, in this submit function, we switch through our intent and we either create or update an item, right? We can delete this print statement here as well. So we're also going to need to take a look at our mutation state and make sure that we succeeded before we dismiss this screen. If we failed, we want to then populate or show our alert and populate that error message with data that comes back from that mutation state associated value in that enum case. So what we're going to do is we can actually go into this create guy right here, and we're going to delete that dismiss call. And we're going to say switch viewModel.mutationState. And we're going to go here and say case.succeeded. And we're going to say let operation. And let me get a space there. And we know that if we succeed, we can just proceed with dismissal, right? So we're going to just dismiss. However, if we fail, we're going to say let operation and our error message. We're just going to call this let error message. Then we are going to say mutation error message is equal to that error message, and is showing mutation error alert is equal to true, right? And we actually don't need this operation guy here, because we know that if we succeeded, we can just go ahead and dismiss. Or actually, what we are going to need that, because we want to make sure that in this case, we are looking at a create operation. So we're going to say guard operation equals dot create else return. And by default, we will just break here because we don't care about the idle state, right? So then we would just copy and paste this code into our update case. And here we would make sure it's an update operation, right? Dismiss. If it fails, we populate these properties here. Default, we break. So once again, we have some copy and pasted code between these two states. The only difference is the checking of the operation and making sure that it's equal to the corresponding update or create operation. So we can refactor this here in a little bit, but what we're going to do first is add a helper to our view model to reset our mutation state. So basically, after each one of these guys, we would basically want to say like viewModel.mutationState equals .idle, right? So instead of just repeating that line of code in multiple places, we're going to just add a helper to our view model to do that. So in our products view model, we're going to go here and add a helper to reset mutation state. And we're simply going to say mutation state equals .idle. And in each one of these situations, we would just call viewModel.reset mutation state and viewModel.reset mutation state. Actually, I think we need to do that regardless of what happens, right? Yeah. So we could just go down here and reset our mutation state. We're going to refactor this in a second anyway, so it doesn't really matter. But I just wanted to illustrate the importance of resetting your mutation state so it doesn't hang in a previous state when you try to reperform or retry an operation, right? Okay, and also this view model is persistent between these two views. So like if you had an error mutation state and you just left it in that state and you dismissed the view and popped it back up, you could potentially have this error message pop up again, which you don't want, right? But anyway, how do we deal with refactoring this code? So basically, guys, we just need to check the operation we're performing, right? So what we're going to do is add a computed property called expected mutation operation. So I'm going to go down here and add a variable called expected mutation operation. And this is going to be a mutation operation. And the autocomplete kind of handled it for us. We're just going to say switch on the intent, and we're going to say return.create, and here we're going to say return.update. Now, in the case of deletion, which we haven't implemented, we could probably do that in another video. We would have a separate delete function. Like right now, the submit function handles both our creation and our update, because we have this all this validation that needs to happen in both situations. So we don't have separate functions for creation and update operations. We have that all encapsulated into a single function. But now basically what we'll be able to do is go here, and we can just grab this whole switch statement and move it outside of this switch statement. So there's a lot going on here. I understand that. So we're going to break it down. Let's delete that there as well. And we can delete these guys too. And clean this up. Perfect. So this is performing our API operation, right? So we're going to create that product. We're going to update that product. So once we're done with that, right, we're then going to paste in the switch on our mutation state. So this is happening after our network call is performed. So now we are going to use this expected mutation operation guy to handle the switch here, so we can deal with both cases. So we're going to say case succeeded, let operation, and we're going to say where operation is equal to our expected mutation operation. And we can remove this guard check now. And we are just going to reset our mutation state and dismiss. And then here, we're going to deal with our mutation error message and our is showing error alert. And that's actually all we need to do. So now our mutation state is successfully handled, and only if we have a success do we dismiss this screen here. So next up, guys, all we need to do is implement our alert. And when the user taps that OK button, we can reset the mutation state there. If we're in this failed state, we don't want to reset that mutation until the user has cleared out the alert, right? So we're going to go and create an alert really quickly. So on our view, let's just do this on our form. I'm going to go here and create an alert that says couldn't save product, is presented, is tied to or bound to that is showing mutation alert guy. We're going to have a button that just says OK. And when the user taps that, we reset the mutation state back to idle. And the message will simply be the mutation error message. So what we're going to do now is implement the ability to show a progress indicator when we actually tap that submit button while that mutation state is ongoing. So we're going to create another computed property to help us determine if we are in like an ongoing mutation state. So we're going to go down to the bottom into this extension here. Are we in an extension here? Let me see. No? Okay. I like wrapping these functions up in an extension, guys, and all these computed properties and stuff. So let's go ahead and highlight all this code and just cut it. And then we're going to make a private extension because all of these things are private to this product form view. And paste all that stuff in there. And because this is a private extension, we don't need these to be private values anymore, functions or variables or whatever. Okay, so our helper is going to be a variable, and it's going to be called is saving current intent, which is a bool. And it's going to say guard case dot in progress. And we're going to say let operation equal the view model dot mutation state. Else we return false. So basically all this is saying is make sure we're in that in progress state, right? And then we're going to say return operation is equal to our expected mutation operation. So we're going to make sure we're in progress, and it could be either create or update, right? So basically if I tap that create button, then my expected mutation operation is creation. So it's going to just make sure that that's the case, and this will then be true. And while that is true, we are going to want to go ahead and show a progress indicator on our button, right? So this is pretty advanced state management. And this all ties in to our networking layer because we have all of these different potential states that we could be in when it comes to mutation operations, loading states, error states, empty states, completion states, success states. Like there's a lot going on. And while this may feel tedious, this is really what it takes. That next level of polish when it comes to not only your UI and your UX, because that's what we're doing right now, but also when it comes to debugging your code, right? By introducing these things, us as developers, this is going to make our life a lot easier when we're going through and testing things ourselves. And when things go wrong, we'll be able to know exactly what went wrong and where. So all of this state management ultimately ties into error handling, which also ties into our networking layer. So let's go ahead and finish out this implementation, guys. We're actually going to make this a Z stack, and we're going to remove this spacing. And we're going to go ahead and say, if where is saving current intent is true, we're going to show a progress view. Else, we are going to show our text with our submit title, whether that's save or create, right? So if we're saving, we show the progress view. If not, we show our submit title. So really quickly, guys, let's go ahead and build and run the application so we can now test this stuff out. So I'm going to go ahead, go up here, and we're going to try to create a new product. Let's just call it mutation state. Price, we can be 99 bucks. Testing mutation state. And we're going to hit create. And we can see here that that transitions into that loading state very briefly. It succeeded because we can see here that we created our new product. So that is working beautifully, right? Now let's see if we can update this product. So let's go here, hit edit. And we could just change it to maybe be mutation. We can hit save. It also transitions there. Ooh, and check that out. We got to test out our error handling just like that. So I guess the product update API just isn't working because this is a 500 internal service error. And we see the server's having trouble right now. Please try again later. That means our user error messages are working beautifully there, handled in our error handling API. So that's looking really good, and that should reset our state. We can try to save it again, and we get the same error. So guys, this is working beautifully. There's nothing we can do about that internal server error. That's a problem with the open API that we cannot fix. So this is looking wonderful. You guys could now go and try to implement this over in the user list view model. It would be the exact same pattern that we did in the products view model, and you could test that out as you wish. I will implement this off camera, and this will be available in the completed source code for this lecture. So hope you guys enjoyed this one. That's mutation state. That's going to be it for this video. We'll see you in the next one. Peace out. And that is actually going to wrap it up for the YouTube version of this course. Guys, if you want access to the full course, the link for that is in the description. You can head over to appstuff.io and check out the full advanced networking course here. This was the first 11 lectures of the course. We have 45 lessons in total for over 15 hours of content. You get access to the source code every step of the way. And we dive much deeper into topics like advanced caching strategies, retry systems, JWT authentication, token refresh coordination, secure token storage, request adapters and interceptors and logging patterns, WebSockets for real-time connections, file uploads and downloads. We cover SSL pinning as well and security best practices. And this really just includes everything you need to build a production networking system in your applications, guys. And this will not only advance your skills as a developer, but it will improve the quality of your applications and your market value in the job space if you're trying to get a job or get a promotion at the job you currently have. And you can become a member here with us to get full access to our full catalog of courses if you guys don't want to just buy the course. But if you don't want a recurring fee monthly or yearly, we also have our lifetime option, or you could just buy the course outright. So make sure you check that out at appstuff.io, guys, and check out our other courses as well on things like interview prep, test-driven development, Swift concurrency, fundamentals, and our Pro Plus app builds are really where it's at. These teach you how to implement the types of techniques we learned in this course in real world application builds with things like Instagram, Messenger, and Tinder. So these courses typically go for $1,000 a pop. I've used these in templates or to build applications rather that cost over $50,000. And you guys can now access them through becoming a member here with us. So I unlocked the Pro Plus courses in the monthly membership. So you guys get full access to our entire catalog with the membership. It's really just such a phenomenal deal. So make sure you check that out. And thanks for watching this one, guys. Make sure that you like and subscribe to the channel and comment below with any sort of content that you want to see from App Stuff here in the future. I've received some requests to do stuff like GraphQL, more with AI. So a lot more awesome content planned, guys. Make sure you follow and subscribe to the channel. Follow me on LinkedIn. I got my socials in the description to this video as well. And we'll see you around. Thanks for watching, guys. Hope to see you inside the full course. We'll see you next time. Stefan here saying peace out.